ध्यान करो क्या होता है।
सर मैंने बताया था मैंने
तब ठीक था ये।
तो पूछता कर रहा था ना आपको पता चलो ऐसे अरे जी मेरे को फोन करके समझा रहे हैं कि आपको अंदर ही बोलना। मैंने कहा जो बंदा को बोलूंगा
तो फर्स्ट सेमेस्टर की क्लास तो चलेगी, सो रहे हो क्या?
क्या होता है नहीं होता है अभी 18 तारीख को याद आया
नहीं, ऊपर से अब 24 को एजेंडा डाला है तो तब कर लेना बात। अभी क्या, अभी मुझे भी बात करनी है सबसे करनी।
Find out that how this universe will run, and for that what kind of computation and calculations were carried out, that how much time it will live, how much mass it can carry, and what kind of force has to be applied for that purpose. So you could see our people are doing all the application areas of mathematics. In fact, in today's scenario, in fact, we were discussing with a man that in present system, mathematics, in a mathematics applied part is missing something, and this become a pretty good work in the domain of mathematics, because classification of numbers, uh, in many ways, like enumerable, all right, and enumerable and innumerable, and the concept of infinity. They have also highlighted the 5 kinds of infinity. In fact, for Indian mathematics, these are the domains which appeals a lot: astronomy, astrology, infinity, computational geometry, all these things. So, if I talk about the Jain era, they have worked a lot. In fact, the mathematicians, to find out the infinity in one direction, to find out the infinity in 2 directions, find out the infinity in the area, find out the infinity everywhere, and to find out the infinity perpetually. They have also worked in the domain of power and exponent, because these concepts were used since the beginning of the human civilization, of the quantification, either that is in form of continuous or in form of discrete. Those concepts are given by the Indian mathematician. And still, in modern mathematics, where technology domain is transforming in multi-way, we are talking about the quantum computing, we are talking about the human transmission, we are talking about technological advancement in form of tagging, sensing, shrinking, and thinking. On these domains where many of the mathematical concepts have been used in form of application.
welcome from TMU and our guest of honors, Dr. Udayji and Dr. Nagendra are eminent dignitaries from the university, Dr. Aditya Sharma ji, Dr. Rakesh ji, convener of this conference, as well as Dr. Puri Madam, taking research to greater heights, and all the eminent dignitaries of the degrees as well as my dear students. It is really gratifying for us to see that the university, especially the FOE as well as the Department of Computing Sciences and various other departments, they are continuously organizing the conferences at the national as well as at the global level. And this is what the real education should intend to do. And since everything has been taken forward by our master of the ceremony, Ms. Neha, and all ancient mathematics, mathematicians, the developments that have taken place have been quoted by Dr. Dwivedi ji. So nothing is left for us to quote further. But to take it on a lighter note, isko band kar dijiyega, jab main ye bolungi. See, I'll give you one narration here, and you will be able to understand as a student of mathematics why the knowledge of the language as well as mathematics is important. And I'll give you a very, very layman kind of incident that happened recently. I was in Delhi and my friend was there along with me, and we had to travel through auto. And she was not very much aware of Hindi numerals, the terminology that we say. कितने लोगों को हिंदी आती है 10, 20, 30, 40 और इसके बीच में जो 41, 42, 43 वो भी आती है ये 10, 20, 40 ये जरूरी है संभल के सुनना ये सब चीज आप लोगों के लिए बहुत important है because Government of India is now putting a lot of emphasis on bilinguality, Hindi English both, because somewhere our youth like you is nowhere. Nahi English, nahi Hindi, but English may be towards your convenience. और आप लोगों ने English को भी हिंदी में लिखना शुरू कर दिया और हिंदी को English में लिखना शुरू कर दिया. So please be careful when you listen to this. I was sitting with her and I was not knowing that she is unaware of the Hindi numerals. So when we went to a place and the person, the auto rickshaw wala, he said ki madam 35 रुपए हुआ. So I said कि okay 35 रुपए दे दो. बोले no, he's fooling us. मैं तो 45 ही दूंगी. Because see, I know this. My mother said कि वहाँ तक जाने में केवल 45 रुपया लगेगा, इससे ज़्यादा नहीं लगेगा. तुम हमें लूटो मत ज़्यादा. मैं 45 ही दूंगी. बोले मैडम मैं तो 35 मांग रहा हूँ आपसे. बोले तो हमें बेवकूफ समझते हो, हिंदी नहीं आती है क्या? और ये लो पकड़ो 45 रुपए. अब 45 में उन्होंने 20, 20 और 5 का दिया. वो तब भी इतना बोला मैडम लोग 5 रुपए तो रख ही लो. जब कह दिया 45 से एक पैसा ज्यादा और कम नहीं करूंगी तो आप ये मेरे को बेवकूफ मत समझिए. I kept quiet because at that time I was not in the state of mind to understand whether to stop her or to him. But that shows कि how much. But that shows कि where do we stand? And this is of my generation I'm talking to you. That is pertaining to my friend. Have you all confronted this kind of situation? तो अगर नहीं confront करा है तो you would be confronting if you are not aware. And I should tell you one more incident that has happened, and this is a recent study in Oklahoma, and that is very important for all of you to understand that as an Indians we stand at a far better place. You see that most of us have the digital watches on our wrists, but in Oklahoma City it was found that the students under 15 years of age, they were not able to comprehend the time when the analog watches were given to them. Analog watches समझते हैं जिसमें 2 सुई बनी होती है, तो उनको पता नहीं था how to comprehend this. So you can understand that mathematics is not something a subject, but it is a subject of reason. It is a subject of music when the reason is taught through some melody. And when we say it's a subject of instruction, that means it is not something that we can avoid by opting for science or arts. It is in your day-to-day life, and if you want to witness that, yes, it is a very important topic for all of you to know, please give something lesser amount to your mates who are not educated, and they will tell you what is mathematics. So in every bits of your moments that take place in your life, mathematics is there. So this was just to let you know that when we talk about ancient mathematics, you should first learn the basic mathematics, and the era that we have witnessed is very, very rich. And as sir has already quoted the mathematicians, so why not we can have the mathematicians from India, from the students like you who can make these mathematicians as your role models. And I should share with all of you that in academics from year 22-23, we have taken up this step that the Indian knowledge system has to be embedded in your curriculum. And all the students who have taken admission in the year 22-23, you are the torch bearers of that new curriculum that we have implemented from this session itself. And you will find a lot of curriculum rested upon the teachings from the Indian knowledge system. So the center has already been proposed and been approved by the Academic Council from this year onwards. And I should tell you, this is a moment for pleasure for all of us to share that the first professor who has been appointed is from mathematics. It's the center of this Indian knowledge system. It's called the coincidence. And when we are organizing conference by the Department of Mathematics, the first professor chair who has been appointed in the Indian knowledge system is Professor Anupam Jain, and he has established the Jain Mathematics Center at Devi Ahilya University in Indore, and he would be one of the privileged members to take this fight forward. And let me also share this thing with all of you, that he is one of the most valuable members in 22 high-powered committee being formed by Ministry of Education under the chairmanship of our Union Education Minister, Mr. Dharmendra Pradhan. So he is now one of our valued members of the university, and we are very hopeful that Department of Mathematics is going to take a full swing under the leadership that we have envisioned. And a lot of things to offer and to discuss with all of you. With the paucity of time, I would take your leave from this podium and would wish all the best for the success of this program, and congratulate the organizers for this wonderful conference. And सर ने अभी बोर्ड रूम में हम लोग बात कर रहे थे कि थोड़ा सा रिवील कर दीजिए कितने पेपर्स आए हैं, कितने ट्रैक्स होंगे, क्या सेशंस होंगे. He said I will make the revelation in the hall itself, but sir, we were still awaiting how many papers are to be presented. And I am very much hopeful that an encouraging response must have been received by the department. With this, thank you so much, madam and sirs, for gracing this occasion. Thank you so much.
Thank you so much, ma'am. You beautifully narrated the importance of language in mathematics in line with National Education Policy 2020, which educates the uses of bilingual method. Thank you so much for being with us today and adding glory to the event with your kind presence. Dear audience, it is a time to showcase the hard work put in the conference by unveiling the conference proceeding. May I please request the dignitaries to do the honor, please. I request the faculty member of Mathematics Department to kindly join the ceremony. All faculty member of Department of Mathematics.
ये वो एक स्नैप हो जाए उसके बाद आ जाइए नेहा जी आप क्या
We would like to highlight that for this conference, we received 87 research papers. Out of 87, 47 were accepted by the committee.
Yes.
Thank you, everyone. Ladies and gentlemen, now I would like to introduce our chief guest, although she needs no introduction. Professor Dr. Rashmi Bharadwaj is a professor and fellow of institutes and mathematics and application. She has 26 years of experience for teaching of mathematics to PhD, postgraduate and graduate students. She has 31 years of research experience and supervised 15 candidates for a PhD degree and 3 are presently working for a PhD degree. She has established non-linear dynamics research lab and mathematics lab in Guru Gobind Singh University. Talking about her awards and achievements, she is a fellow of Institutes of Mathematics and Application UP July 2021 onwards. Visiting Associates 2022, 2023, 2002 and 2005 of Inter-University Center for Astronomy and Astrophysics, Pune, India. National Board of Higher Mathematics, Government of India Research Project from 2022 onwards for 3 years for rupees 16.8 lakhs. She is a member of Sectional Committee for the section of Mathematical Science, including Statistics for 2020 and 2021. 2019-2020 by Indian Science Congress Association, official body under Department of Science and Technology, Ministry of Science and Technology, Government of India. Government of India, Ministry of Earth Science, India, Meteorological Department, IMD awarded 27th Biennial Museum Award. Cash prize rupees 50,000 and citation with co-author on IMD annually 15,000. Guru Gobind Singh University Indian Quality Assurance felicitated with a cash prize of rupees 10,000 for being recognized in the international sphere. Lifetime Achievement Award 2022 in Non-Linear Dynamics International Multidisciplinary Research Foundation Executive Council, India's 73rd Republic Day Excellence Award and International Day Education Award 2022. IMRF India registered Niti Aayog, Government of India. She has received Lifetime Achievement Award 2021 International Scientist Award on Engineering, Science and Medicine awarded by VDGOOD Professional Association on December 4th, 2021. She has received Best Researcher Award 2020 International Research Award on New Science Inventions. Science Father registered by Ministry of Corporate Affairs, Government of India. The Best Research Award 2013, 14, 2012, 13, 11, 12 for Guru Gobind Singh University. UTC Major Research Project 2012-2015 Government of India worth rupees 12.5 lakh. Young Scientist Award 2004-2008 All India Council of Technical Education AICTE Government of India rupees 10.5 lakh. Junior Research Fellowship JRF from Department of Science Technology DSP to University of Delhi, Delhi. Senior Research Fellowship from Council of Scientific and Industrial Research to University of Delhi. Zakir Hussain College Merit Scholarship for 5 consecutive years. 55th Indian Mathematical Society Annual Conference Scholarship awarded by University of Delhi. National Science Mathematics Olympiad Contest Certificate. She has authored 3 books, 3 patents, 175 research paper and 9 books. Talking about her professional achievement, she has appointed as consultant examiner, head examiner, evaluator, moderator for various examination of central, state, government organization and foreign university. She has subject expertise in various selection committees of Central State Board, University Resource Person, and chair technical session in workshop, conference, seminar, Central Board, State Board, University, government organization, and foreign university. Without further ado, I would like to request ma'am to allow us your expertise on the field.
Thank you very much. First of all, I would like to thank the organizer of this conference, and especially to Professor Dwivedi, Professor Jain, and Professor Puri, and especially to the mathematics department who is in continuous touch with me that whether I will give the consent or not. And I think 3 days continuously they are in touch with me. But surely you will come and be this time, because earlier 2 years I was in online mode connected with the mathematics department. So this time they want me to be in the offline mode. Even I'm not keeping a good health from the last 3-4 months, but because they insisted, so I came and I'm here. Anyway, thank you very much for giving me such an honor and a respect. So I'm not going in on what is mathematics, how to teach the mathematics. I'm simply telling you what is the application of mathematics. Because we are discussing about what is mathematics, and now in the computer era, you know that what is mathematics. If I say what is integration, you know that formula. But how to apply that is important. So, abhi, like sir ne kaha, we are studying here, Aryabhatta discovered the zero. But I said that because he is a computer department head and the principal and all those things, he is studying only because we invented the zero. That's why now the binary system is there and the computer is there. Because without zero invention, this computer will not work. So all the things are there because the mathematician multiplicated there. So anyway, I will start that. So I have taken a sum to say that what is that and what kind of the slide is this. If we are seeing this slide, this is nothing but gave solitary wave. I gave this lecture in SRM University, Chennai. And you know that when we are talking about the tsunami waves or all those things, and at that time, our nuclear reactors were not working. And we have the boiling reactors. सबसे ज़्यादा जो tsunami में नुकसान हुआ था, जितना भी चेन्नई पोर्ट पे और जितने भी हमारे reactors थे, nuclear reactors, all these they are damaged. As I am associated with the Bhabha Atomic Research Center and DRDO also. So now in India, we have developed the technology where we are not using the boiling reactors. And these are the techniques where we are using, this I'm not giving this, but the soliton waves we are using there. Next is, this is, abhi sir ne infinity ki baat kahi, there are so many infinities. And this is the knot which is developed by the Ramanujan. And this is nothing a shape of the infinity. Simple knot hai, sab bandhte hai rassi. And this is nothing but he tied it up in a form of infinity and then gave the concept or the thing of the concept of the infinity, which is nothing a simple concept which I will give you, that a simple series which he summed up to the infinity. Now, abhi bhi sabne kaha ya main from my childhood, because I belong to the फैमिली जहाँ शायद कोई पढ़ा भी नहीं और मैथमेटिक्स तो बहुत दूर की बात थी। और whenever I go to anywhere, सबसे पहले क्वेश्चन होता है आप क्या कर रहे हो? If I say I am a professor, this subject can be considered as a humanities or mathematics. Oh, we are afraid of mathematics. So these are the some ways. Mathematics is completely useless. All we are saying this. Even we are saying that. Mathematics are the avid soulless Greeks, which पता नहीं किस पे भूत की तरह से we are one. Same way, all mathematicians are mad. That I am listening with the where the mathematics is. But I will show that what is mathematics. Mathematics is whatever heart surgery is possible, that is only due to the mathematics. And so the modern world will not exist without the mathematics. As I said that now we are talking about the computer. We have the set theory. But if we are not developed the set theory and the compartment of the set theory, your computer is no good. So this is the set theory which is developed and then the mathematics is there. Axioms we are giving in probability now the 3 axioms which are based on the set theory and which is the base for the development of the computer. So your mathematics, and I will give you the latest technology, how these are related with the ancient mathematics. With maths, you can tell the future and of course save the lives. I, with the Professor Datta from the Bhabha Atomic Research Center, we have developed one model. I think earlier I have presented also here, which is the RD model. And that was published, and in the month of June 2020, we declared that the COVID period will remain for 464 days. Yes, in June 2020, we declared the decline era of that is in the month of October 2021. And the same prediction that at that time, the data was not sufficient, but still we developed that model and we predicted and almost we succeeded in getting the almost form of that, and that paper was published in Chaos Solidon. So this is your research letter. This is a life, and I will show that how in a heart and everywhere you have a mathematics now. As we have said that it lives in our heart as art and music, and now everywhere we started with the Saraswati Puja, that is also a chanting of the mantras, and mantras are based on a mathematical. Either we talk about the Ramayana or any kind of that. Sundar Kand, if we take, that has a particular number of duas, and every dua has a particular number of the lines. So that is the beauty of our ancient mathematics. As we have done the prayer of the Saraswati, that is nothing but a mathematical animation of the, and this is made only in a simple computer program. Now everyone see the file. Anyone analyze that it is a mathematics? You have a mathematics in your hand. No one analyze at any time. And everyone born with your hand and you have a mathematics in your hand. Now see that this is a first line, which is known as a heart line. And this is nothing but a y equal to exponential term. And we say that our heart line grows exponentially. Now, if you see the last line, which is our lifeline or luck line, this is nothing but y equal to log s. And that's why it is a very slow, our life or luck changes very slowly, which is, it is changing. But we consider it is not changing because it is a slow process. But if you take the as a composite of these functions, then you are getting a nothing but y equal to s, which is a identity function and which is nothing but your headline. So always we said, या हमारे ऋषि मुनि भी कहते थे कि अगर किस्मत बदल रही है तो अपने दिमाग को शांत रखो. So that is the way, because whatever you are doing, that always is to be y equal to s. Then only you grow. So this is always in hand. Always you have a mathematics. It is your power to analyze. अभी जैसे मैडम ने कहा हिंदी का, I was in the visit to some schools in Delhi from the NCERT, and one of the student asked me the question कि madam what is the use of mathematics, हम क्यों पढ़े? I simply asked that कि हमें mathematics पढ़ाया जा रहा है इसलिए हम भाग रहे हैं, but if we see the hawkers जो daily काम करते हैं, आप सब्जी वाले को देखिए, शायद वो मेरे से पहले कैलकुलेशन कर लेगा। अगर मैं उसे कहूँ 100 ग्राम धनिया ये वो मेरे से पहले कैलकुलेशन करके मुझे बता देगा, और उसने तो शायद कभी मैथमेटिक्स पढ़ा ही नहीं, वो क्योंकि उसकी लिविंग फूड से रिलेटेड है, क्योंकि अगर उसमें कुछ उसने कमी करी तो दैट विल बी गिविंग अ लॉस। तो जब हम मैथमेटिक्स को एज अ पार्ट ऑफ आवर लाइफ कंसीडर करेंगे तो शायद हम पढ़ेंगे, अगर फोर्सफुली स्कूल में पढ़ाया जाएगा तो शायद मैथमेटिक्स हम नहीं पढ़ेंगे। एंड वी आर ऑलवेज, और शायद मैं दिल्ली को बिलोंग करती हूँ और जितने भी पेरेंट्स से मैं मिलती हूँ सबसे पहले उनका यही होता है हमारा बच्चा मैथ्स में कुछ कर नहीं सकता तो कोई ट्यूशन बता दीजिए या ट्यूटर बता दीजिए सो दैट वी कैन पुट इट। क्यों? क्योंकि आप खुद मैथ्स से डरते हो, इसलिए आपने वो फ्रस्ट्रेशन और वो डर आप बच्चों पे थोपते हो, बच्चे आगे कुछ नहीं करेंगे। सो ऑलवेज ग्रो देम इंडिपेंडेंटली, कोई डर नहीं होना चाहिए। दिस इज माय पर्सनल व्यू as my both sons grow up, and one is a civil servant and one is doing a PhD MS program in US. So both are good in mathematics, and but I never taught them, and they are not forced to learn the mathematics. So anyway, our life miss, we have a mathematics in our hand, so that is इससे पुराना कुछ नहीं हो सकता। तो जब से हमारी एग्जिस्टेंस है तब से मैथमेटिक्स एग्जिस्ट कर रहा है। आप सब इनवर्स फंक्शन बताते हैं तो कोई कभी समझाता नहीं है व्हाट इज अ फंक्शन एंड व्हाट इज अ इनवर्स फंक्शन। ओके, अब अगर फंक्शन है कैट ate the fish, तो इनवर्स फंक्शन क्या होगा? fish eats the cat, but this is not the, this is only a visualization because then the conditions are there, it has to be satisfied. So this is a simple way to teach the students at the earlier stage what is a function, how it exists to be. मैं खुद अपना बता रही हूँ, when I came to the 11th class, और 11th class में जब मुझे डेरिवेटिव पढ़ाया गया and I asked that what is the application or what is that, तो सिंपल ये कह दिया it is a rocket science and you have to use there. Even I did a PhD in astronomy and did in the satellite calculation and all those things, but still I didn't understand what is the derivative. शायद हमें भी ऐसे पढ़ाया जाता, it is nothing a rate of change। सुबह मैं सबसे डिस्कस भी कर रही थी कि अगर हमें डेरिवेटिव ये पढ़ाया जाता, it is a change, only rate of change। If you have anything it changes its rate, then it is a derivative। So these are the simple way to teach, or I say to learn the mathematics, to understand the mathematics। सेम वे, और ये सब शायद हमारी एग्जिस्टेंस से ही सब चीजें एग्जिस्ट कर रही हैं, पर हमने कभी एनालाइज नहीं किया कि मैथमेटिक्स है क्या। फंक्शन है, फंक्शन का रेट चेंज हुआ, यू हैव अ पोटैटोस and I know that the younger generation didn't eat that, but if you are coming to the first derivative of that, finger chips, everyone likes that, so it is nothing a reformed or the rate of change of the potato। Then you come to the second derivative, and this is nothing but chips, and Haldiram and all those are earning only by making that potato as a chips, taking a second rate of change। So see that the how mathematics transform and the earning also। Same way you have a coffee beans, coffee powder and the coffee। So only the, I only say that I am not teaching a mathematics, I am telling that at every point you have a mathematics, only you have the eyes to visualize that, okay, how you will find out the mathematics in everything। This is the integration। What is integration? Summing up, which we say that area and all those things, you have a different pieces, you glue up and you are taking a something that is nothing but it is a integration। Now I am coming to the एंशिएंट मैथमेटिक्स और हमारे गुरुज और मंत्रास की बात की जाती है, तो शायद जो भी हम मेडिटेशन या कुछ भी करते हैं वो हमारे खुद की बॉडी से शुरू होता है, और बॉडी में भी ब्रेन को शांत रखना सबसे बड़ा काम होता है, क्योंकि अगर आपका ब्रेन शांत है, काम है, तो देन यू कैन डू इट, अदरवाइज शैतान का घर है। The first equation is nothing, which is a force. Means if you are doing nothing, it is nothing but force equal to mass and gravity, which is like that. But if you have a some thinking or something, then the two particles interacting with each other. And if two particles are interacting, then what is the force? So that is the Gm1 m2 by r square. And like this, now come to the last bit. And see that we say that कि meditation बहुत आसान है, शांति तो बैठना है, शांति मुद्रा में बैठना है, but how difficult it is, see the mathematical equation also, because you have to cut off from all the sources, all the direction, and then you have to focus only on yourself. So that is required all powers. So it has all the negative numbers, and no one asked that everywhere we have a positive earlier than interacting. Why in the later stage it comes to be the negative number? Why it is be negative? No one. Because you have to cut off from everyone. So cut off from everyone means you have to go to the negative towards the जो संसार में बस रहा है या लग रहा है. So you have to cut off from that. That's why it is a negative, and that's why you are coming to be the stage which is say at a शांत stage or a guru stage or the शांति, मतलब जो हमारे गुरु और ब्रह्मांड में exist करता है. So these are the simple, and you say that the whatever be the values, these are given at that time. Now earlier अभी सर से बात हो रही थी कि मैथमेटिक्स इज प्योर, but I never considered mathematics as a theory, and that is the reason I developed the research lab in the mathematics in our university, in all the colleges, and now students can visualize what is a mathematics. So mathematics is theory, वो सबने पढ़ी है, but I will say that it is an art, and I will show that how it is an art. It is a language, क्योंकि आपका कंप्यूटर mathematics. It is a process of thinking, computer thinks, which is now artificial intelligence, machine learning, soft computing. You are saying about that. It is a practical, and practical is we are existing, so it is a practical. I will show you that how in our body our complete mathematics. सबने खाया गोभी है simple. Okay, broccoli. What is the beauty? Why I put it here as a mathematical model? इसकी क्या beauty?
बताओ भाई मैथ्स वाले.
कुछ तो होगा ना, क्या है, क्यों मैथमेटिक्स में ब्रोकली और मैं गोभी एकदम ले आई? नहीं. अब अगर इसका कोई भी पार्ट, एक छोटा सा पार्ट तोड़ो, not union, that is of course a gobi complete is a union of a small part. If you take a small part of that, अगर आप उसे zoom करेंगे, what you got? Which kind of shape you are getting? Again the gobi, okay? And that is the beauty. और ये हमारा ancient mathematics की development है, which I will show. और शायद आप सबने भी visit किया होगा, हमारे जितने भी temples हैं, जितने भी structures, monuments हैं, all are based on this theory, and this is known as, अभी मैं बताती हूँ. So this is a cauliflower. अब मैं थोड़ा सा not take it as a mathematics, वैसे ही line नहीं समझ लो. If you have a plus sign, okay, what we did, computer आ रहा है तो आसान भी है. ये जो plus है, you repeat on all the lines. Okay, again you did the same thing, again you do. What is, this is your initial, this is first, second and third iteration. Now you see in the third iteration how complicated structure you got it. But the beauty of this structure is if you take a small part of it and zoom in, what you got? Again the structure. So जब भी life में कोई complicated structure आता है, we take a small part of that we did a study of that and then we tried to analyze it with that complicated structure. और तभी हमारे यहाँ कहा गया आदि से अनादि और अनादि से अन और फिर उसमें कुछ नहीं है. That is the reason. शून्य से infinity और infinity में अंदर सारा शून्य है. So this is the how complexity grows. You see that, and I will show you that recent hours all the telecommunication industry is based only on this simple mathematics.
Grid computing. And
Yeah.
all these grid computing and all.
Yeah. So all these are the example. Our kidney has this structure. Same way, I'm coming to that one. Broccoli has this structure. And this is known as a fractions or fractal. So what is the definition of this? It is an extremely irregular line or surface formed by an infinite number of similarly regular sections. Okay. Physically, it is a rough geometric structure, but mathematically, it is a set of points whose fractal dimension exceeds its topological dimension. अच्छा मैं पूछूं what is सबने पहाड़ तो देखे होंगे कौन सी शेप होती है बच्चों वाली मत बताना बेटा पहले बता now you are not a small kids जो पेंटिंग में ट्रायंगल बनाते हैं प्राइवेट की कौन सी शेप होती है कौन सा कौन होता है किस एंगल से वो प्राइवेट लगता है हमारे चलो हिमालय पर्वत का कौन सा कोण है These are not. वही मैं आपको दिखाने जा रही हूँ सब बचपन में ना वो स्फीयर्स ऐसे ऐसे बनाते थे किसी ने भी गोल स्फीयर नहीं कभी भी बनाया क्योंकि स्फीयर कभी भी जो आपके क्लाउड्स होते थे वो स्फीयर होते ही नहीं सभी ऐसे ऐसे बनाते थे लाइक ऐसे ओके क्योंकि क्लाउड्स जो है कभी भी स्फीयर थे ही नहीं सेम वे अभी आपने कहा माउंटेन्स कौन है पिरामिड है बट ये कहां से कौन है सिर्फ किसी ने एनालाइज नहीं किया कभी ना नेचर में बैठो और तब तुम्हें सारे खुद ही जवाब मिलते हैं क्योंकि नेचर इज फुल ऑफ मैथमेटिक्स सेम वे कॉस्ट लाइन्स हमारी कंसीडर की जाती सर्कल्स but these are not circles. Same way, शायद फिजिक्स में शायद 6th-7th में पढ़ाया जाता है लाइट ट्रैवल इन अ स्ट्रेट लाइन ठीक है जब बिजली चमकती है कभी किसी ने स्ट्रेट लाइन में चलते हुए देखा तो इसका मतलब हम जो पढ़ाते हैं गलत पढ़ाते so light never travel in a straight line okay अब ये सारे कॉन्सेप्ट हमारे पुराने एंशिएंट मैथमेटिक्स में सब डिफाइंड है बट विद द इन्फ्लुएंस ऑफ द यूरोपियन एंड अमेरिकन्स क्योंकि उन्होंने एक वैक्यूम में क्रिएट करके दिखा दिया कि लाइट ट्रैवल इन अ स्ट्रेट लाइन बट इट नेवर ट्रैवल इन अ स्ट्रेट लाइन बिजली चमकते हुए सब देखते हैं आई एम नॉट गिविंग यू एनी एग्जांपल व्हिच इज अ कंट्रोवर्शियल टू द एग्जिस्टेंस ऑफ द नेचर सब ये देखते हैं बिजली कभी स्ट्रेट लाइन में नहीं चमकती है गिविंग दिस टाइप ऑफ फ्रैक्शन एंड ऑल दिस अगर थोड़ा ध्यान से देखो सभी फ्रैक्टल स्ट्रक्चर सब रिपीटेड स्ट्रक्चर्स बेसिकली मैंडलब्रॉट ने 1975 में ये टर्म कॉइन की थी फ्रैक्टल और मैंने स्पेसिफिकली ये वर्ड को लिया है बिकॉज ही इज कंसीडर्ड एज अ फादर ऑफ फ्रैक्टल पर हमारा अगर शंकराचार्य में देखा जाए तो ये टर्म पहले से डिफाइंड थी बट वी हैव नॉट गिवन दैट नंबर एज अ फ्रैक्टस वी आर नोइंग दैट एज अ अभिन्नम और द ज्योमेट्री और द फ्रैक्शन ओके और ऑल हमारे जितने टेंपल्स हैं या जो भी स्ट्रक्चर्स हैं वो इसी फ्रैक्टल पे बने हुए हैं आई विल शो यू आई थिंक सबने एक स्ट्रेट लाइन देखी है और सब मैथमेटिक्स के क्योंकि स्टूडेंट है और सभी ने कैंटर सेट पढ़ा है क्या होता है लाइन है 0 to 1 divide it into 3 parts, take out the middle part. Okay. अब जब आप ये 0 to 1 है, divide it into 3 part, middle part ले लिया, same way repeat करते जाओ. Cantor did this process कि वो कहाँ जाएगा? क्या ये 0 पे जाएगा? Where it will converge? आप तो कैंटर थोड़ा सा मैथमेटिक्स लगाओ, कैंटर सेट तो पढ़ा है सबने? नहीं, उसने भी छोड़ दिया था, कैंटर ने भी छोड़ दिया था, उसे नहीं समझ में आया था. उसने कहा था इट इज अ मैथमेटिकल मॉन्स्टर, क्योंकि उसे खुद नहीं समझ में आया कि कहाँ जा रहा है. एंड दिस इज द फर्स्ट फॉर्म ऑफ अ फ्रैक्टल. ओके, एज अ एविडेंस आई एम सेइंग ओनली फ्रैक्टल, बट दिस एग्जिस्ट सिंस द Shankaracharya era in the Indian scenario. और बहुत कम लोगों को पता है कि इसकी एप्लीकेशन we are using it in the mines. You see that mines में similar structures पे cracking जितना mining होती है वो same structure करती है. One of my friend was the director of the Gujarat mine board and he was surprised कि हम जो स्ट्रक्चर लगाते हैं you are doing it perfectly, and this is nothing that how they are finding the crack and then accordingly where they have to put the target to find out the mines from that. अब मैं थोड़ा सा how we have developed this because I have to show you the real application आज की जितनी telecommunication industry है which is based only on these lines. So it is a geometry. Basically, it is nothing but a iteration process. And what you have to take? You take a line, okay? And in a line, divide it into 3 parts. Remove the middle part, and instead of that middle part, form the 2 more lines. Okay? Now these all 4 steps is a one process. Okay? Now what you have to do? Repeat the same process on each line. So this is the second iteration. This is the third iteration. And now see that. This is the 5th iteration. Okay. अब शायद क्लाउड्स की कोई शेप समझ में आई है? क्लाउड्स की शेप क्या होती है? These are the cloud shapes. Triangle में you take a line and then join, you are getting this structure which is a cloud structures. How to find out its dimension? शायद सबने यूक्लिडियन ज्योमेट्री पढ़ी है, टोपोलॉजी पढ़ी है. लाइन की क्या डायमेंशन होती है? इतना तो नहीं, इतने तो थोड़ा बहुत तो बेटा फर्स्ट सेकंड में तो मैथ्स पढ़ेंगे. लाइन की क्या डायमेंशन होती है? 1. ट्रायंगल की डायमेंशन बेटा 3. हाँ तो गुड. ओके, अगर मैं इस फिगर की पूछूं, इसकी क्या डायमेंशन? 3. जब ट्रायंगल की 2 होती है तो कंप्लीट ट्रायंगल भी नहीं है बेटा. How we have to find out? Okay, simple way calculation का. जितना ओरिजिनल पिक्चर थी और जितने नए बने, नए कितने बने? 1 2 3 4. ओरिजिनल कितने थे? 1 2 3. Okay, so it is nothing but simple new pieces by earlier pieces. It is log 4/3 because neither it is a straight line nor it is a triangle. That's why its dimension is neither 1 nor 2. It comes out to be the number which is log 4 by log 3 and it is 1.26. तो हमारे क्लाउड्स जो है ना, तभी ना तो स्फीयर और सर्कल में ही लगते हैं क्योंकि उनके डायमेंशन ही 2 नहीं है. ओके, इट इज 1.26. ये हमारे इंडियन नंबर सिस्टम में अभी सर ने कहा हम डीपी यूज करते थे. शून्य नहीं था, 0 नहीं था, बट शून्य था. और जितने हमारे ग्रंथ और जितने हैं सब में शून्य पहले से डिफाइंड है. आर्यभट्ट ने उसको सिर्फ शून्य का एक नंबर डिफाइनिंग नंबर 0 को दिया था कि दिस इज नोन एज अ 0 बट शून्यम सहस्त्रम हम सारे वर्ड्स यूज करते हैं। पास्कल ट्रायंगल अभी बात कर रहे हैं, एंड अगर इसकी ब्यूटी देखो, ये चाइनीज अर्थमेटिक ट्रायंगल है, और अगर पास्कल ट्रायंगल की ब्यूटी देखो, व्हाट यू आर डूइंग, you are adding 1 1 and the 1 plus 1 is the middle part, and which is nothing a form of a Fibonacci is also the same thing. तो आज के जो कंप्यूटर का बेस है, हम जब कहते हैं कि कोई प्रोग्राम हमारा कन्वर्ट कर गया, प्रोग्राम एग्जीक्यूट कर गया, व्हाट डज इट मीन? आप कुछ भी लैंग्वेज लिख लो, अगर प्रोग्राम ही नहीं, आउटपुट ही नहीं आएगा, व्हाट डज इट मीन? फिर तो कंप्यूटर बेकार है। अब एग्जाम में नॉर्मली होता है कंप्यूटर ही बेकार होता है, क्योंकि आप लोगों की तो गलती होती नहीं है, एग्जीक्यूशन होता नहीं है प्रोग्राम। क्यों नहीं होता? बिकॉज जो उसकी कन्वर्जेंस है, वो जो मैं अभी शो करूंगी कि क्या नंबर है जिसमें जाकर अगर प्रोग्राम कन्वर्ज करता है। ओके, सो दीज आर ऑल द ट्रायंगल्स व्हिच आर ऑलरेडी नोन एट दैट टाइम। अब नाउ आई एम कमिंग टू द इंडियन हिस्ट्री और इंडियन मैथमेटिक्स। ज्योमेट्री इज द मेन which is the contribution given to the Indian, and अब ये shapes हैं, और do you know that the Ram temple जो है वो भी develop किया गया उसका model, which is also based, and that model was developed using the MATLAB. वो पूरा का पूरा mathematicians ने develop किया है राम मंदिर का जो model है, और उसका पूरा MATLAB प्रोग्राम है, पूरा का पूरा कि कैसे उसके, actually I am not going in detail, पर जो मंदिर का जो बनता है उसमें एक गर्भगृह होता है, उसके बाद एक परिक्रमा गृह होता है, उसके बाद आउटर सरफेस होता है। गर्भगृह वो होता है जहाँ पे मूर्ति रखी जाती है, और आपको सरप्राइज होगा कि दैट इज द सेंटर ऑफ ग्रेविटी। और शायद केदारनाथ में भी जब क्लाउड बस्ट हुआ था, बिकॉज आई एम अ पार्ट ऑफ दैट क्लाउड बस्टिंग कमेटी, और उसमें केदारनाथ के टेम्पल पे कोई प्रॉब्लम इसलिए नहीं हुई थी क्योंकि जहाँ शिवलिंग है अंदर, वो पूरा सेंटर ऑफ ग्रेविटी था, और जो उसके पीछे जो डाइवर्जन हुआ था, दैट इज आल्सो अ बाइफर्केशन, और जो शिला आई थी जिसने पानी को बाइफर्केट किया था। और लेकिन जो मंदिर का गर्भगृह होता है वो हमेशा उस जगह पर बनाया जाता है जो पुराने मंदिर, आई एम नॉट टॉकिंग अबाउट द लेटेस्ट वन, उनको उस पॉइंट पे लिया जाता था जहाँ पे कि बिल्कुल सेंटर ऑफ ग्रेविटी ऑफ अट्रैक्शन हो, सो दैट इट विल रिमेन्स टू बी द सेम प्लेस। So these are all the structures. If you see, all are the fractal structures, और ये राम मंदिर का भी स्ट्रक्चर पूरा का पूरा fractal based है। And see that all these are the same, which is coined in 1975, but these exist still earlier in our Indian mathematics. ये this is also a form of a fractal, which is nothing but the sum temple, and it is a fractal based. ये सारा है, if you want slides are here, तो सारे टेम्पल्स जितने भी बने थे सब फ्रैक्टल बेस पे बने हुए, और ये रामेश्वरम टेम्पल है। जब हमारे पास कोई टेक्नोलॉजी नहीं थी, as said by the Americans and the world कि Indians are not good in technology, we are not good in anything, and see that this was made in 1740. Our Rameshwar temple, and that has a 12 pillars, और सारे मर्ज कहीं से भी किसी भी डायरेक्शन से देखोगे वो एक ही डॉट पे मर्ज करते हुए मिलते हैं। So this is the beauty of the mathematics, which you can easily visualize. Same all these temple, it is in Varanasi, which again has the fractal structures. All these are Khusrau temples. All are this a सबसे ब्यूटीफुल पार्ट। आपने सबको पता है हमारे कितने शिवलिंग्स हैं जो which considers, और ये आठों के आठों जितने शिवलिंग हैं, these are made without GPS, और सारे is in the same line। सीधा सबका latitude longitude सारा दिया हुआ है, all are in the same straight line, and see that this is the Indian mathematics which was developed at that time, and we are able to visualize how at that time they have calculated it. Actually, that is some sort of a one forum is from the Prime Minister where they are doing the analysis. So at that time we did that study. Also, और जो राम वर्डिक्ट आया उसमें बहुत बड़ा रोल था उन सबका, और उस टाइम उसकी पूरी कैलकुलेशन मैथमेटिकल मॉडल पे की, और जो अब नया मॉडल भी डेवलप हुआ है वो भी पूरा मैथमेटिकल मॉडल बना है. And now this is a triangle. I am repeating the same thing. And ये वैसे भी गेम की तरह खेल सकते हो मैथमेटिक्स. And you got a cloud. So these are the shape of our clouds. The dimension is some. Everyone has the mostly the 1.26 dimension. So our clouds or trees are having a fractal. And this is a beach in the Karnataka. Okay. इसको आप एनालाइज इस तरह से करो. Actually, the physicists, geologists, all are struggling, and all the computer scientists are there. How long is the
आगे आगे हाँ.
taking in this way, you are getting a length as a higher. But if you are taking in this way, you see the both the ways. One is this way. Which one is giving you the accurate? Which one? Red one? Okay, I will show you. This is the coastline of Great Britain. One way is this one, but it is not calculating the dimension. This is the way of calculating, and this is nothing but a fractal. And all our beaches has the same coastline wave. So it is actually finite long, but it has a finite dimension. और तभी इसलिए कहा जाता है कि कोई भी सुनामी के बाद भी लाइफ चल रही है, तो जो भी विनाश है उसी के अंदर में फिर जिंदगी है. तो everywhere disaster has a life itself, because अनादि में फिर शून्य है, तो infinity में फिर zero है. So these are this. I said that you have a hand. You do the experiment. ज़्यादा काम करना है. Same repeat the process. You have a hand, then hand, then hand. Do that. अब ये वाला जो है आजकल सारे फ्रैक्टल एंटीना यूज होते हैं आपके मोबाइल से लेके टेलीकम्युनिकेशन इंडस्ट्री में. एंड दिस इज द थिंग. एक सिग्नल मतलब एक एंटीना में यू हैव द डिफरेंट वेवलेंथ की सिग्नल्स रिसीव कर सकते हो. Because my son is directing to the Ministry of Telecommunication, so that's why I was surprised when he showed us a chip of that. I said, "This is a Koshka." He said, "How you know that thing?" So this is nothing, but I will show you that these are the triangle. What we did, we joined the middle point and remove the part. Same thing we did it, and now I show you that this triangle is how useful it is, and it has our all the systems. Now see that. What is this? It is a hollow piece because we removed everything, but still it contains the maximum area. And this is the chip which is used in. I'm not going in. And this is now used in arts as well as in fashion designing. This is a fractal antenna. आजकल कोई भी बड़े बड़े शायद हमारे टाइम में जो टीवी में लगते थे, आप लोगों ने तो शायद वो एरा नहीं देखा होगा. वो जो एंटीना ऐसे गोल 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 लगते थे, फिर कभी बारिश हो गई या कुछ हो गया ऊपर जाके ठीक करना पड़ता था. Now we have invented these antennas, and the beauty of this antenna, you see that it has a 5 different layers. One is this, and it receives different signals at a different wavelength. तभी आज पहले मोबाइल में आप सिग्नल एक जगह खड़े होकर सुनते थे. आज with the movie you are able to listen everything and able to do that. And see that. ये अभी मैंने कॉश तक दिखाया था. This is a chip of that. which is used in your mobiles. Okay, so see the mathematics used in the everywhere. This is a merger sponge, which is the, and now see that it is nothing but a computers. आजकल आप करते हो कि चिप में सारा डेटा आ जाता है. How we are storing? I'm showing you in a fast way. What is this? You see that. So it is containing. Right now we are able to calculate 20 to power 6 में 64 million cubes इस figure में, and it is a hollow, complete hollow, but it contains a maximum volume. और जितना दुबई में और इतने जो स्ट्रक्चर्स बनने all are based on the fractal based, जो सो कहीं पर उठोगे तो कोई और डायरेक्शन में, which are based on the fractals. So this is this small structure बना रहे हैं. All these are based on these ones. और इसकी डायमेंशन देखो 1.67. अभी मैं इंफिनिटी की बात कर रही थी, वो जो नॉट थी सिंपल डिस्टेंस ना 1 + 2 + 3 कितना, वो तो बता दो. बट इफ इट इज गोस टू बी, then it is known as an infinity, but is it infinity? और ये शायद अब तो रामानुजन पे पिक्चर सबने ही देखी है. हार्डी रामानुजन ने जो एसिम्प्टोटिक थ्योरी पब्लिश की थी वो इस पे बेस्ड था कि कैसे हम डिफरेंट वेज में पार्टीशन कर सकते हैं. तो मैं सिर्फ एक व्यू दे रही हूँ. आई एम नॉट गिविंग यू द हाउ टू राइट डाउन ऑल दिस थिंग्स. ये उसी के permutation combination है, how we develop the formula. और ये फॉर्मूला है जिससे we calculated at that time, जबकि पाई की नॉलेज नहीं थी और एक्सपोनेंशियल फंक्शंस का नहीं था. And which gives this knowledge. सिंपल इटरेशन प्रोसेस पे बने हैं, एंड दैट इज इटरेशन प्रोसेस. क्या है इनिशियल कंप्यूटर्स में क्या करते हो, एक इटरेशन के बाद दूसरा लूप लगाते हो, ये करते हो ना. इनिशियल वैल्यू कुछ दिया, उसके बाद सेकंड लूप. सो x1 इज नथिंग बट x0 स्क्वायर प्लस कांस्टेंट लाइक दिस थिंग. और हमारे को फाइंड आउट करना है कि क्या ऑर्बिट आएगा. अगर मैं x स्क्वायर प्लस 1 से शुरू करूंगा, सेम 0 है, तो फर्स्ट वैल्यू इज 0, नेक्स्ट इज then next what is that big number? 677. And if you are taking next one, it comes to be 4,58,336. Okay, so see that in a just a one iteration how big number you are getting it. And this is the way when we are visualizing the infinity. So it is simply a visualizing a infinity. It is nothing but it is a fractal part. Then if you start with 0, it merges to the 0. Okay. This is the converging point. But if you are coming to be the -1, then 0, -1, 0, -1. So what you are getting? It is some points are going towards the 0, some are towards -1. So you have a 2 cycles. One is towards 0 and one is towards -1. Same way if you have this one, if you have this number z square plus iota, you start with 0. Next क्या होगा? Iota. If you are putting iota, then -1 plus iota. If you are putting -1 plus iota, minus iota. If you are putting minus iota, then so it is only between these 2 points. Okay. Also based, this is the figure which was created by the mental world, and the beauty of this picture is it was not a closed figure. जितना भी तुम इसके अंदर जाओगे, you are getting the same picture repeated inside of that. You see that. Again, you are getting the simplest. And it is nothing but z equal to z square plus c. Take a straight line, divide it into two parts. Numerator को numerator में add करो, denominator को denominator में. So 1 plus 0 is 0, 2 plus 1 is 3. So this is the 1/3 part. Same way, next part is 2/5 and like this thing. Every part has a number. And this is the beauty of this structure, it is not closing. You see the beauty that everywhere it is repeating. And see that how it is repeating. In our nature, we have everywhere the mathematics. As I see that in the nature, mountains are your fractals. Same way you have the शंख. किसी ने देखा है उसमें क्या क्यों इतना उसकी आवाज को चेक किया जाता है, क्या वो कारण है? All are based on the mathematical structures. और सिंपल सा स्ट्रक्चर है. ये एक मैं मॉडल दिखा, मॉडल नहीं है कुछ भी, इसको वैसे मत लो. ये सिंपल एक इक्वेशन है. xn plus 1 is based on the previous equation. अगर तुमने r को 0.5 लिया और इनिशियल वैल्यू 0.5 ली, तो कुछ इटरेशन के बाद यू आर गेटिंग अ 0. ओके, दिस मींस कुछ टाइम बाद ये जो भी पॉपुलेशन या जो भी होगा वो डाई आउट हो जाएगा. सेम वे अगर 0.8 है देन थोड़ा लंबा चलेगा बट अगेन इट डाई आउट. 1 पे भी सेम, 1.5 पे it is converging towards some point, but the beauty what I want to show, as we are coming to 3.2, you see that it is repeating to 2 points. Okay, and when you are coming to the 3.5, it is repeating to the 4 points. 3.5, it repeating to 8 points, and this is nothing but in mathematically it is known as a bifurcation. Your one cell is divided into 2 parts, 2 into 4 parts, and like this thing. और ये जो कैंसर में ट्यूमर सेल्स होती है उनकी ग्रोथ मॉडल है. और जब कीमोथेरेपी सेशंस होते हैं, अगर सपोज इस पॉइंट पे कहीं पर हुआ तो ये सेल अभी ग्रो कर रही है. अगर इसको इस पूरे स्ट्रक्चर पे होगा तो ये पूरा डैमेज हो जाएगा. सो दैट इज अ वेरी इंपॉर्टेंट की कैसे सेल्स की ग्रोथ को कंट्रोल करना है. इसलिए सर्जरी या कोई भी चीज आजकल नॉट ओनली अ बायोलॉजिकल और अ डॉक्टर थिंग, इट इज बेस्ड ऑन द कंप्यूटर्स. सो अगर किसी भी पॉइंट पे सपोज यू इस पॉइंट पे अगर स्टक आउट होता है, ये पूरा सेल का ग्रोथ चलता है. अदरवाइज अगर यहाँ पर हुआ तो ये सेल ग्रो कर. और ये हमारी बॉडी की ऑल द फ्रैक्टल कैनोपीज आर देयर. ये हमारे लंग्स का स्ट्रक्चर है. कोविड में जो सबसे ज्यादा इम्पैक्ट आया था लंग्स पे इसीलिए आया था बिकॉज इट इज मल्टीप्लाई एंड इट इज हैविंग अ इम्पैक्ट ड्यू टू द फ्रैक्टल प्रॉपर्टीज. एंड सी दैट this is the reason its growth is going on. You are not able to visualize which cell is now on the what direction. और बॉडी के पार्ट में जब मैंने कहा था कि हमारी बॉडी खुद मैथमेटिक्स है, ब्रेन से सिग्नल विद इन अ फ्रैक्शन ऑफ सेकंड एवरी पार्ट इट ट्रैवल्स because we have a neuron which has the fractal properties. Because it travels, it is has a similar property and it travels signal within a fraction of seconds. These are the kidney. Everywhere you have a fractal structures. These are the all fractal models. And this is the model. Actually, as I told you that in mass and with this we are working on this. Actually, breast cancer ke liye we are finding the fractal dimension of chromatin, which is if we are able to find out the fractal dimension of this chromatin, then easily we are able to detect and that which portion we have to tackle or which cell we have to tackle. So still with the DRDO in mass and HAR, we are working on this project. As I told earlier, you are all binary. हमारा DNA sequence किस पे based है? थोड़ा तो बताओ. DNA में क्या होता है? क्या हेलिक्स होता है? ACGT, ओके, अब मैं इसको कंप्यूटर से रिलेट कर 0 0 is here A, okay, 0 1 is C, 1 0 is G and 1 1 is T. ये तो आती है लैंग्वेज फाइनली। अब इसका जितने भी स्ट्रक्चर बनेंगे उतने क्रोमोसोम्स के स्ट्रक्चर्स यू हैव इन द थ्रू आउट दैट एंड यू सी दैट। इसीलिए किसी की डीएनए सीक्वेंसिंग नहीं होती। ओके, only I am giving you the glimpses that everywhere you have a mathematics. ये पेपर एक केमिस्ट्री बेस्ड पेपर where you have again in the chemical जब एनालिसिस करते हो सरफेस पे जितनी भी लेयर्स बनती है ऑल आर मैथमेटिकल मॉडल्स। ये आपका अभी जो सर से भी डिस्कस कर रहे थे कि जीरो नहीं होता तो आपके कोई स्ट्रक्चर और कोई कंप्यूटर नहीं एग्जिस्ट करता। ये कोट आई लाइक स्पेसिफिकली, if you like fractals it is because you are made of them, and if you don't like because you cannot stand to yourself, because our complete body is based on the fractal, it is a fragmented. Okay, so हमारा जो हिंदू शास्त्रों में या हिंदू धर्म में या कहीं पर भी, मैं आई एम नॉट सेइंग हिंदू धर्म में सब only Hindu, it is a part of that, it has a Jainism, Buddhism, everything, सब में वहाँ पर पार्ट जो किया गया है दिन का पार्ट किया है कि that is fragmented, divided into the fractions and that is the part. Okay, ये हमारी कंप्यूटर लैंग्वेज है which is nothing. अब ऑटोमेटा में you are doing this theories, I think जो कंप्यूटर के लोग होंगे या स्टेट्स होंगे, so it is nothing but a fractal structures and this is the Benjamin structures. केमिस्ट्री में how the rings are combining, you are getting answer nanotechnology में हो रहा है, that is only the base of these. तो सारा जो है मैं सिंपल सा ये कह रही हूँ कि लास्ट में कंप्यूटर सिमुलेशन आता है which shows you that how mathematics is helping you in all the directions. आजकल फ्रैक्टल रोबोट काम कर रहे हैं, ये मेरा भी लेटेस्ट पेटेंट भी पब्लिश हुआ है। उसमें यह है कि आई थिंक जो
हाँ मैं आपको ये
पहले लोग जाते थे और शायद कुछ अगर कैजुअलिटी हो जाती
से निकालो अभी।
यूजिंग दिस फ्रैक्टल रोबोट्स, उसमें क्या है बिकॉज़ ऑल पार्ट्स आर सिमिलर, तो जो पार्ट डैमेज हो जाता है वो दूसरा से रिप्लेस कर देता है। तो जितना सफाई में जो चॉकिंग होती है सीवर्स की, उसमें पहले मैन पावर यूज होती थी। अब नाउ वी आर यूजिंग दिस टाइप ऑफ द फ्रैक्टल स्ट्रक्चर्स व्हिच इज नोन एज अ
और ये बोल तो नहीं है मैम ही है रश्मि बात।
इसी पे मेरा पेटेंट आया है। ये फिबोनाची नंबर की बात हो रही थी, व्हाट इज दिस ग्रोथ मॉडल, पर इसकी ब्यूटी ये है कि ये इस नंबर को कन्वर्ट करता है। जब कोई भी प्रोग्राम इस नंबर पे कन्वर्ट करता है तभी उसकी एग्जीक्यूशन होती है। तो तुम्हारा कंप्यूटर में अगर ये नंबर आ रहा है which is known as a golden set number also, अगर गोल्डन नंबर आता है तो प्रोग्राम की एग्जीक्यूशन होती है, अदरवाइज यू आर ऑलवेज इन अ लूप। ओके, सो दीस आर द ब्यूटी। और ये जितने भी स्ट्रक्चर्स हैं जो मैं स्टेबिलिटी की बात कर रही हूँ वो सब इस स्ट्रक्चर के हैं। शायद वो जो लेबर ने काम किया वो उन्हें गोल्डन नंबर नहीं होता था, but they have constructed this structure in such a way which has the stability which is based on this number. And now see the beauty of this number. Everywhere you see that this is also a pattern, and what is a pattern? It is a repetition of the process. In nature also everywhere I said that everywhere you have the mathematical models. All are the fractal repetition. This is also you see that how it is started. It is started from 0 and going to infinity. हमारा जो शायद पिकासो की पेंटिंग का क्या ब्यूटी थी, क्या रीजन था, why it is so costly. अच्छा, कौन से फेस को भी said that it is a pretty face while it is looking pretty, what is the reason? it should has the similarity. मोनालिसा पिक्चर का भी जो ब्यूटी का कारण था because it has a fractal structure, a fractal face which has the similarity from all the angles, and that's why that is the picture which has the similar structures. Now I'm trying ये सारा, I'm not going in much detail. What is that? Simple ये support vector machine you are using. It is the model which is segregating, as the kernel is there which is segregating the two parts of that. और यही model we have developed or used in the COVID model to segregate the infected and the healthy people. So you have to use the like quarantine or the lockdown. What is this? These are the act as a that time as a kernel. ये सब rough sadness everywhere. ये MRI, CT scans, everything is based on the mathematics. I simply want to close up that one. ये ट्रांसमिशन का रेट था, मैं ज्यादा डिटेल में नहीं जा रही हूँ. सिंपल आज की डेट में क्योंकि बूस्टर्स सबको वैक्सीनेशन हो चुकी है, तो हम इस मॉडल पे काम कर रहे हैं. कोई अगर इन्फेक्टेड भी है, क्योंकि सब हम ऑलरेडी वैक्सीनेटेड हैं, so it is not going to impact any person. आफ्टर कुछ बात, ये मॉडल था जो हमने मई 2020 में काम किया था, which was published, and here we have taken all the factors. और इसमें हमने इंडिया का ये डेट दिया था कि roughly May 2021 it will be over, and that was Albert Einstein हमेशा कहते थे I don't believe in mathematics. Now I'm coming to show you the only the something.
ऐसे नहीं चलेगा, ये मैं कह रहा ना थोड़ा एक दो दिन
का मैं एप्लीकेशन दिखाऊंगा. ये सारी लेटेस्ट टेक्निक्स हैं जो हम यूज कर रहे हैं. गूगल ने अभी जो मैथमेटिशियंस को हायर किया है, एंड दिस इज द सिंपल मॉडल. अब ये तुम्हारे ऊपर है कि कितने बिलियनर और मिलियनर तुम बन सकते हो. इसमें सिंपल सा है कि हाउ मच इंफॉर्मेशन वी कैन शेयर विद द वेबसाइट्स. ये कंप्यूटर लैपटॉप एक से दूसरा, ओके. ये नेटवर्क है, मैं डिटेल में नहीं जा रही हूँ. हर एक नेटवर्क पे कितने कंप्यूटर कनेक्टेड हैं, और गूगल ने जो रिसेंट स्टडी करने के लिए मॉडल दिया है, anyway that has to be connected 1 billion computers at a line then to make the network. This is the recent challenge first given by the Google. Now connect it and try to find out that in how many ways you can find out that. Anyway, this is simply जो मैंने पहले दिखाया था कि भगवान ने शायद कुछ सोचा होगा, बिग बैंग किया, and then they created the mass and he was bored, so he created a force जिसको कि हमने बिग बैंग, we know that बिग बैंग से पहले किसी को कुछ नहीं पता, बट बिग बैंग के बाद सबको पता है क्योंकि it is defined by the rules and regulations. So अभी भी बात हो रही थी कि मैथमेटिक्स क्या है. So it is not about numbers, equations, computation or algorithm. It is about the understanding. कि आप कैसे समझते हो वो important है. It is neither pure nor applied. It is simply a feeling. Once you understand, it never leaves you alone. So it is your way how to see the mathematics, and I always believe on the Picasso words, always doing that which I cannot do to understand how much I can learn or how can do it. So now I'm showing you, all we know that in this world we need the love, and this is also a mathematical one. L is nothing. What is that? Exponential function. Xy equal to hyperbolic function. Xy equal to 1. O is the circle. V is the modulus function, and E is nothing but the x equal to -3 sin. Okay. Anyone? I said earlier that it is a music also. So all the dancing step is nothing but a mathematical name. So lastly, I will say that thank you for this. I tried to keep it as a simple as to give a glimpses of what is mathematics and how you have a different applications. Of course, questions पूछ के तो खुद अपने पैरों में कुल्हाड़ी मारने वाली बात होती है. But फिर भी I have asked that any questions or any comment. And my email ID is if you want any query or anything, it is there. So no comments. वैसा कुछ नहीं, सब दिमाग के ऊपर से निकल गया. Anyway, thank you very much.
Thank you so much, ma'am. Actually, I'm feeling myself short of the word to express how wonderful the lecture was. It was truly commendable. And we truly appreciate your sense of commitment that in spite of not physically well, you are here with us. We need to multiply this word thank you many times to express our gratitude. Thank you so much, ma'am. Moving ahead, we would like to introduce our distinguished speaker, Dr. Uday Singh, Associate Professor, Department of Mathematics, IIT Roorkee. His area of interest are approximation theory, foreign analysis. He has been supervising students for PhD degree and till date 7 degrees have been awarded under his supervision and 3 are still going. He has membership of several professional bodies, notable among them are regular member for American Mathematical Society, life member of Forum G Analytics, life member of Indian Mathematical Society, life member of International Society for Analysis, Application and Computation, life member of Indian Science Congress Association. Till date, he has to his credit 20 research papers published in a journal of great repute, whereas 5 papers in one book series. Till date, he has contributed 6 chapters in the book. May I please request you, sir, to kindly address the gathering. Students, you are requested to remain seated, please. It's a request to be seated.
So I am thankful to the Institute Administration and organizers of the conference for inviting me for a lecture here. So, dear participants and dignitaries, I will speak something here about my research area connected with the history, and that is development in the area of Fourier analysis that was started by Joseph Fourier when he invented the idea of Fourier series. Okay. So I hope all of you are aware about Fourier series. What is the Fourier series? So my talk will be basically divided into 2 parts: some historical background about the Fourier series, and then convergence and approximation with the help of Fourier series. So he is Joseph Fourier, whose full name is Joseph Fourier, was born in 1768 and died in 1830 in Paris. He was known as a French mathematician and Egyptologist also, and he was an administrator also. And he published his, we can say, revolutionary work in France Journal of Mathematics, the Analytical Review. So maybe so While doing the problem of heat conduction, he invented his solution can be represented in the form of a series, and that series does not have powers of x. This series has terms of sines and cosines. And one more thing is here, is this idea took, I think, 15 years to get published. Till 15 years, when he submitted the paper, the mathematicians were unable to decide whether it can be accepted or not. It is not like nowadays in 3 months or 6 months we are getting the publication. But after taking 15 years, his idea is useful today also, and not useful, it is very useful. Some of you may be aware that how to write Fourier series. If we have a function f, this can be integrated. So expression of this form a not by doing some constant plus summation a n cos n plus b n sin n. Here a n and b n are in the these integrals. So any integrable function can be represented in this form. This is the basic idea behind this.
The cordless might be na. उसको बंद करो.
So this expression is basically Fourier series where a and b n are known as the Fourier coefficients. If I calculate this infinite series up to finite. If I calculate this infinite series up to n terms, so we will get this form, and this form of the series is known as trigonometric polynomial. You know, algebraic polynomials of degree n. So a type of expression having finite number of terms is called trigonometric polynomial of degree n, provided an and bn are not simultaneous. So in previous admit that Fourier series given in 1.1 is convergent to function f is only when it is the Fourier series. But they do so because they assume that most of the functions encountered by them are like so that their Fourier series is always convergent. But when we will go in the rigorous mathematics, it is not always true that a Fourier series is convergent, number one, and the series will converge to the function from where we have calculated the Fourier coefficients. Let us see some fundamentals related to that. I will take a class of L2 functions. L2 minus pi to pi here is a class of functions which are 2 pi periodic and which are square integrable on this interval. Then accordingly we can have inner product of two functions with that integral minus pi to pi f e. Orthonormal difference in L2. All these functions are L2 functions which they are square integrable. And if you consider this sequence of functions in the interval minus pi to pi, you will observe that all these elements are orthogonal. The linear space of trigonometric polynomials is the sequence of L2 given by this. This setup, the form of Fourier series will be like 3.1, where Fourier coefficients will be given by these formulas, right? And if I substitute this constant a naught by under root 2 pi by capital A naught, n by under root pi by capital N, and capital Bn by small bn upon under root pi, so I will get the previous simplest form capital A and capital B. So now what is the convergence? I have infinite series, so So what will be sum of that series? And that infinite series is a series of functions. So when we will add individual terms, so we are supposed to have some function. And every function in the series is sine or cosine or multiple of x, right? So whatever will be the sum of that series, that will be a periodic function. So sines and cosines are 2 pi periodic function. Right? So if series is convergent, so there will be some function whose function which is equal to sum of the series. So that function has to be a periodic function. So here is the result. We have that series can converge if f is 2 pi periodic function integrable on the interval minus pi to pi. If f is piecewise smooth function, then the Fourier series of f converges to ft minus plus ft plus by 2 at every point. So at the points of discontinuity, the sum of the series will be equal to average of the right and left hand limit. If our point P is a point of continuity, then it will be ft, it will be ft, then series will convert to the ft. So at the points of continuity, series will convert to the value of the function. Now, can we say that every series of this form is a Fourier series? It is not always true. Any trigonometric series you cannot say it is a Fourier series. For that we have certain criteria. So if we let the 2 pi periodic extension of an absolutely delayed integrable function on minus pi to pi as the Fourier series, this which may or may not converge pointwise, then sine coefficients Pn are such that series n is equal to 1 to infinity Pn upon n converges. So if this criterion is satisfied, only then the series will be Fourier series. So to answer the last question, consider the trigonometric series sin nt upon log n. So when we will make analysis of this coefficient Pn, basically here the coefficients of cosine term are 0. All the ans are 0. Only Pn is 1 upon log n. So this is decreasing to monotonicity. If you apply test of convergence, you will see that the criterion, Pn upon 1 upon n Pn. So this series is divergent. Okay. So the series is not. This series is not basically Fourier series. Okay. If it has been Fourier series, then this condition has to be satisfied. This condition. Okay. Yeah, if the trigonometric series of this form converges uniformly minus pi to pi. Now I'm saying only trigonometric series, not the Fourier series, right? Converges uniformly on the interval minus pi to pi, then the limit is a continuous function whose Fourier coefficients Kn and Pn. The limit is obviously 2 pi periodic. Don't say that the previous series to which we said not a Fourier series was also uniformly convergent, because the interval of uniform convergence also matters. So our choice of interval will also affect whether given trigonometric series is Fourier series or not. Now let us see an example. So look at this function. Fx is 0 in the interval minus pi to 0, and from 0 to pi it is 1. And otherwise outside the interval is fx plus 2 pi equal to fx. Such type of definitions are called periodic extension of the function. We have values of the function in the interval minus pi to pi, but outside the interval we can use the periodicity. Now if you calculate Fourier coefficient, so we will have these values, and we will have this fx is almost equal to this. If this series converges to fx, then I can use the sign of equality. Right? Now you can note down here our function fx is discontinuous function, right? It is not continuous at 0, right? So can we approximate a discontinuous function with the help of a polynomial in the powers of x? This we usually call Taylor series approximation. For the Taylor series approximation, functions require so many conditions. Up to certain order, functions not to only be continuous, which derivative could also be continuous. Right? That is the advantage of that a discontinuous function can be approximated by a function of this form, and this function has many nice properties that it is continuous, it is differentiable up to any order, and its graph is a smooth graph. And here also at x is equal to 0, what is happening? Value of the function is 0. The value of the function is 1, but value of this series will be 1 by 1. Right? So at the point of discontinuity, what is happening? If you look at the right and left hand limit, then their average will be 1 by 2. So that criteria is satisfied here. All other points where function is continuous, value of the function and value of the right hand side space will remain the same. So there are some advantages of the Fourier series. As I told you, this what type of advantages we have over the Taylor series. Everything is in here. Sines and cosines are much more versatile prime elements and powers of x. The graph is smooth and it can be differentiated up to any order. Right? Polynomial after a certain order of variation will give you always 0 value, but it is not in case of sine and cosines. Earlier I discussed the formula for a function which is 2 pi periodic, which is 12 periodic, then our formula will be like that. Now let us see one more example with the help of graph. Fx is equal to e raised to the power x in the interval minus pi to pi, and function has period 2, not 2 pi. Here period is supposed to. So if you write Fourier series of this function, Fourier series will be of this form. And if you draw the graph of e raised to the power x from -1 to +1 and truncate this series up to 10 term, means n is equal to 1 to 10, so we will get this blue graph. If I take S30, means 30 terms of this series, so graph is coming closer to the function. Okay. So as number of terms will increase in the series 4.1, the graph of the series as well as graph of the function will coincide. Okay, so this series is approximating the given function. So there is a one more thing that is called conjugate Fourier series. So if I write fz is equal to in this form, k is equal to 0 to cn z is to the power n, where z is a complex number and cn is a complex constant given by an minus ikn for n greater than or equal to 1 and a naught by 2 for n is equal to 0. Now if I substitute here z is equal to e raised to the power ix and equate the real and imaginary part of this series, so I will get this series as well as this series. This expression is called Fourier series, and this conjugate part is called the conjugate of the Fourier series. Now, you see with the help of graph how function is approximating or converging, the series is approximating the function or the series is converging to the function. Right? What will be the mathematical formulation for the convergence? Okay. Maybe you know how to find the convergence of the series. You find the sequence of partial sums by summing first n terms and then take the limit as n goes to infinity. If that limit is finite, you see series is convergent. So with that formulation, we will have, suppose Sn axis means sequence of partial sum from the previous, and Snx can be written in this integral form like this. We have your new function dnx minus 2. Basically, Snx is transform of ft, where dnx minus t works as a kernel, and this dnx minus t or dn is called discrete kernel. Right? Now, if I want to see convergence of Snx with f, these should measure the deviation of Sn with fx, means Sn minus fx. So if I write Sn minus fx, we will have this type of expression. Okay. if n goes to infinity and this right hand side goes to 0, then we will say that Sn x goes to fx as n goes to infinity. So whole thing depends on dnp and this expression under the sign of integral. Right? The upper estimates of the Sn x minus fx in terms of n determine the degree or order of approximation of f by Sn x. So if I keep my this right hand side in n only, right? And whatever function or expression in terms of n I have, that determines the order. Okay. Suppose it is of say something less than or equal to constant time n, then it is of no use. Because then n goes to infinity, right hand side will go to infinity. If it is something like constant into 1 upon n raised 1 upon n, then it is useful for us because 1 upon n will go to 0 as n goes to infinity, or in other words, Sn x will goes to fx. Now, there is a term Gibbs phenomena. Okay. At the points of discontinuity, as I told you, there is a phenomena. Whatever Fourier series you take, at the points of discontinuity, there are peaks. When we draw graph of the Fourier series, so we will find peaks in the graph of Fourier series at the points of discontinuity. Here are the points of discontinuity. Okay. So this was observed by mathematician Gibbs. So this is called Gibbs phenomena, and you can see it here. Again, take a discontinuous function, and we will have graph of the function like this. When we will consider Fourier series of this function and compare with the graph, say only one block I have taken here. When I am taking 10 terms, okay, and 30 terms, okay, so 30 terms are more closer than the 10 terms. Okay. And if I consider the average of the sequence of partial sums, that is sometimes known as C0 sums, okay, so we will have this type of trigonometric Fourier series that approximate better than the SNS, means the partial sums of the original Fourier series. So here is what is the C0 sum in Fourier series, and based on that we have phasor theory. Phasor theory will help us basically. We will move from the class of continuous or discontinuous function to the L1 class, right? So it is a larger class. The series minus 1 raised to the power not convergent. Can we attach a value to this series? I think. What will be the value of this series?
बताओ भाई मैथमेटिक्स वाले
तो बोलो.
हाँ
It will be either 0 or 1, right?
एससी एमएससी पीएचडी सब बैठे
So in that case, we cannot say that this is convergent. Okay. If yes, such a process is called summability. Now, here my question is: when you check the sum of an infinite series, what to do? First term plus second term plus third term and so on. If you keep on adding, your process will not end, even your life can end, right? Because you cannot find sum of the infinite number of terms. It means we have to design a process by which we can find sum. So that process with us is what? We write the sum of first n terms and then consider the limit of that sequence. That limit is finite, then we say this is the sum of the series and series is convergent. That sum is not actually actual sum of the series because we are having infinite number of terms. We are only attaching some value to the infinite series by some process. Process is that consider the sequence of partial sums and take the limit. Here also we can design another process, right? That process is take the average of the sequence of partial sum, then form a new sequence Tn. Like this here, this is the sequence of partial sum, this is the average, and plus 1 terms are here divided by n plus 1. If this new sequence Tn is convergent and we are getting finite value, then we can see that our original series is convergent. Now here process is different. Okay. So such type of processes are known as summability in the literature. And if I apply this process to value of this series will be 1 by 2. That will be the fixed value. How it will be 1 by 2? You can construct SK for this. What will be SK if K is even? So it will be 0. If K is odd, it will be 1. Right? So here it will be 0 plus 1, 0 plus 1 like that. So finally it will be 1 by 2. Now what is the Fazor theory? Okay. So Fazor extended the convergence criteria for a larger class of the function, that is Linear integrable periodic functions. Okay. And he gave the result that if f belongs to L1, the Fourier series is given by this. And he told this. What happens if we apply C1 means? So this is the main result of Fazor. For 2 pi periodically extended f belonging to L1 minus pi to pi. Linear integral. It will have continuous as well as discontinuous functions. At every point t where ft minus means left hand limit, ft plus right hand limit exists, the Fourier series of ft is C1 summable to ft minus ft plus by 2. If f is continuous on Ct, then C1 partial sum sigma and converges uniformly to f on Ct. Okay. So here also I will use partial sums, and again I will get this integral form of the average of the sequence of partial sums, that is denoted by sigma and t. And here Fnx is known as the Fazor kernel. Earlier one was the discrete kernel. And we will show that this limit of this term is left hand limit, limit of this term is right hand limit. So one can verify from Fourier analysis that ordinary sums does not have these properties. As the summability includes more functions in the class of functions which have convergent Fourier series. So I am stopping here. So now your question will be what is the application of this? Okay. So what I discuss is if there is something in our hands which can approximate a discontinuous thing by a continuous and differentiable. Okay. So the signals which are discontinuous, they can be, suppose input of the signals is discontinuous, but output can be continuous. Okay. That is the advantage of this study. Right. That's all. Thank you.
Thank you so much, sir. Your presence and gentle words are source of encouragement for us, and we will ever remain grateful to you. The success inspiring personality who lends charisma to the occasion, and we are extremely grateful to our revered chief guest and esteemed keynote speaker for accepting our invitation and adding laurels to the event. So now I would like to request Professor R.K. Dwivedi to present a memento to Professor Rashmi Bhardwaj as a token of our gratitude. Now I request Dr. Vipin Kumar, convener of the conference, to present memento to Dr. Uday Singh sir.
आजिए कोई बात नहीं, एक फोटो में आजिए, थोड़ा क्लोज जी। थैंक यू।
I would like to request Dr. Vipin Kumar, convener of the conference, to present memento to Dr. Uday Singh sir.
Yes. Good. जी.
Last but not the least, I would like to request Dr. Ajit Singh, Head Department of Mathematics, to present a memento to Dr. Nagendra sir.
Okay. Right. Yes.
It's time to enjoy the lunch now. So I request the dignitaries to kindly proceed for the lunch, and the students of mathematics will remain seated here.
Hello, hello. Am I audible? No, let me increase. हेलो हेलो। अच्छा अच्छा, ये जा रही है मेरी वॉइस ना? अ, हमने तो ये किया हुआ है, अनम्यूट तो किया हुआ है। अब आ रही है क्या? अच्छा, अब जा रही है ना?
यस सर, आपकी आवाज आ रही है।
ओके ओके, ठीक है। अब कब से स्टार्ट करना है बता दीजिएगा। अच्छा 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 अच्छा, कोई इंट्रोड्यूस करेंगे या फिर डायरेक्ट? ठीक, ठीक है ठीक, ठीक है ओके, ठीक है ठीक।
हाँ यस सर। तो उनको मैसेज करो, मैसेज से रीड कर लें। वो नहीं सर हटाएंगे, फिर वो बोलेंगे। आपको तो वहां से जाएगा ना आवाज, तो उनको आवाज नहीं जाएगी मेरी भी। क्यों बोल रहे हैं ना खुद ही। हाँ, मतलब अगर यहाँ से हम रिप्लाई करेंगे उनको तो आपके से जाएगी ना। आपके
नहीं नहीं सर, वो मुझे आइडिया लग गया था, मैंने कहा हो सकता है आप बिजी ना हो गए हो कहीं इस वजह से, क्योंकि मुझे पता है सर। हाँ तो नासिक surface area लगेगा is sufficient.
Good afternoon all. I, Dr. Paragan Kumar, am feeling honored to introduce you all with Professor Nagen Kumar from Department of Mathematics, MM College, Ghaziabad. Professor Nagen has completed PhD from Rupki University, presently known as IIT Rupki in 1992 in magnetohydrodynamics and plasma physics. He has teaching experience of more than 28 years of taking several reputed education institutes such as MMS College, Ghaziabad, Manasthali University, Manasthali and KDK College, Muradabad. He also has 3 years of professional experience as project officer to assist computer-aided design of the reservoir operation at the National Institute of Hydrology, Roorkee. His area of specialization is the MSc Fluid Dynamics, Plasma and Solar Physics. He has supervised 5 students in different areas of solar physics, plasma physics, and magnetohydrodynamics. He has completed 2 research projects funded by University Grant Commission in Delhi and also published 28 papers in international journals of review and also write 9 books with reputed publishers. He was awarded by several national and international awards such as the Research Associateship by SIR, Associateship Award by 3 times by IIFA Pune, INSA Visiting Fellowship Award by Indian National Science Academy Delhi, UGC Research Award by University Grant Commission in Delhi, and he was also selected for the bilateral exchange program of research to visit Poland for 4 weeks during 2011 to 2012. He has also received the Commonwealth Fellowship International Award by Association of Commonwealth University Commonwealth Scholarship Commission in United Kingdom for the year 1998 to 99. He did his many academic visits of scientific institutions in many institutes of reputation such as ISC Bangalore, IIFA Pune in Vista program. He has also visited St. Andrews University, Scotland for a year for the postdoctoral studies and in Institute of Physics, UMC, in Poland for 3 weeks during 2010. He has also visited UK, Germany, Japan, Turkey, Poland, USA, South Korea for research collaboration and to present research work in international conferences. He is also a member of several leading academia research bodies such as Plasma Physics Society of India, Astronomical Society of India, National Astronomical Union, etc. In addition to this deep command of academic and research, he also had a good command on Hindi, English, German, and Russian languages. With this brief introduction of Professor Nagen Kumar, I welcome and invite him in this conference to enlighten us with his knowledge and experience. Sir.
Yes. Great, sir. Mic नहीं, mic कर। जी सर।
This is our son.
तंग कर दिया यार।
पुराना गुड़गांव था।
Climate, weather, and understand many mechanisms in astronomy and astrophysics, in particular morphing process. This is the only start to see closely. But for me, it is important to study solar heating by electricity wave. There is a puzzle still. Several sources are working all over the world. Surface of the sun is has temperature 6000 Kelvin, but outer atmosphere of the sun has temperature 1 to 2 mega Kelvin. So corona is very hot in comparison to the surface of the sun. Why it is so? The several physicists all over the world are working on this puzzle. They have not solved yet. It is still unsolved problem. They have suggested several mechanisms to understand this problem. Heating by resonant absorption, heating by phase mixing of waves, heating by displacement of electric waves, heating by magnetic reconnection. I am working heating by displacement of LSD wave. I have published one paper called heating by LSD wave in AMEA in 2006 on this topic. Now, sun is not a solid sphere. It is a massive ball of hot gases, and it consists of hydrogen and helium. In particular, hydrogen is 25%, helium about 24%, and some small quantities of carbon, nitrogen, oxygen, and hydrogen. So, thus, the main gases in this on sun are hydrogen and helium. It is an average star. It has no solid surface because it is a massive ball of hot plasma. Now I have mentioned here vital statistics about the sun and earth. In order to compare, I have written here earth radius and sun radius and
various parameters, radius, volume, mass, density. We can compare here the sun parameter with the earth parameter. Radius of earth is 6,400 kilometers, and sun radius is 109 times the earth radius. Volume is 13 to 10 to 5 times the earth volume, and mass is 330 into 10 to the power 3 earth times earth mass, but density is very less. Interpreted to density of earth, it is 1/4 times of earth density. The distance of the sun from earth is 23 into 10 to the power times the earth radius, that is 149 kilometers. Surface temperature is 6,000 Kelvin, and core temperature for the interior part, central region of the sun, it is called core. Its temperature is 15 million Kelvin. Surface rotation, if we observe from the equator, the sun rotates on its axis once in about 25 Earth days, while we observe from the pole, it rotates once on its axis in about 35 Earth days. Luminosity of sun is more than about 626 watts. सुबह ज्योति जी ने मेंशन किया था, हनुमान चालीसा में एक श्लोक आता है, युग सहस्त्र योजन पर भानु लीजो ताहि मधुर को जाना। तो ये युग मीन्स 12,000, सहस्त्र मीन्स 1,000, योजन मीन्स 8 mile, and if we calculate this yug into सहस्त्र yojan, it comes out 96 into 10 to the power 6 mile. If you multiply it by 1.6, it comes out 1,536 into 10 to the power 5 kilometers. So that is nearly approximately equal to the calculation done by NASA. So sun is not a rigid body. It is not a rigid sphere. So different part of the sun rotates with different speed. Part of the sun rotates faster than the poles of the sun. North pole, south pole. These are the poles. Two poles, north or south. Equator means red line. You see there. So see red line. This is the equator, and these are poles, north pole, south pole. So this middle part, equator part, rotates with faster speed than these poles. So that's why we call it the solar rotation, the differential rotation. Now, I will discuss solar interior. The solar interior has three regions. The inner one is core, central region is core. Here, the enormous amount of energy is produced by if 4 hydrogen atoms fuse here to create an helium and enough amount of energy. Core. Here, nuclear thermonuclear reaction take place because of high temperature and high density. Nuclear reaction burn every second about 700 million tons of hydrogen into helium here in core, and energy produced in core, energy generated in core, transported through the radiation zone. There is another layer of line above core, that is radiation zone, and through this zone, energy is transported by radiation. The photons travel here at the speed of light. They bounce so many times through the dense material that they use about 1 million years to escape the sun. Above this region, there is another region, convection zone, and through this zone, energy is transported by convection, just like boiling stew. how does the core gets its energy? As I have discussed, density is 20 times of density of iron here. Density is very high, temperature is very high, 15 to 10 to the power 6 Kelvin. So hydrogen, 4 hydrogen atoms fuse together and create in helium atoms and enormous amount of energy. Yeah, please. ये आवाज आ रही है मेरी? Here we see the variation of temperature so these regions for radiative zone, convection zone. The temperature here is 15 million Kelvin here in core, and it decreases slowly, rapidly, and then here rapidly, and here is the photosphere, surface of the sun, and here the temperature is 6,000 Kelvin. It has atmosphere. Sun has atmosphere. There are 3 layers in the sun. 3 layers. The first layer is photosphere. Then chromosphere, and then above chromosphere there is corona. Corona, corona. Yes, sun is corona. There are 3 layers. The first layer is photosphere, and it is a very thin layer of 100 kilometer thickness. Most of light emits from this layer, and its temperature is about 6,000 Kelvin. Above this layer, there is a narrow region of about 2,500 kilometer thickness, and the temperature here rises from 6,000 Kelvin to 20,000 Kelvin. Corona is our uppermost layer of the sun. It is visible during total solar eclipse of the sun as perfectly white crown surrounding the sun. जब आपने सूर्य ग्रहण देखा होगा तो एक चमकदार चक्र वो चारों तरफ घिरे हुए व्हाइट क्राउन सा दिखाई देता है सन को, तो वो कोरोना कहलाता है. Corona, in corona we see various features including streamers, chrome, lobes, flares, various features of coronal features we see during solar activities. Corona extends up to several solar radii and has a brightness equal to full moon. This is the surface of the sun. Surface of the sun is divided into, it has granular, photosphere has granulation structure, and it is divided into many convective cells of thickness 1,000 to 2,000 kilometers thickness. Yeah. This is the strip of coronal region. Chromosphere is derived. This word chromosphere is derived from chroma, means color. During solar eclipse, we see the chromosphere because the temperature is very high here, 20,000 Kelvin. So hydrogen at this temperature, at this high temperature, emits light, and that gives off reddish color. That's why we call it chromosphere. Corona, this is derived from the Latin word crown. Now here we see the sunspot. Sunspot appear as a dark spots on the surface of the sun. They appear in pair. Here we see one sunspot, another sunspot. And this is the darker region. The temperature of the darker region is less than the temperature of this outer region. Their lifetime is from lifetime of a sunspot is from several days to several weeks, but very large sunspots may live for several weeks. Here we see the sunspot appearing in pairs. Sunspots have a strong magnetic field, about 1,000 times stronger than the sun surroundings. The two sunspot pair have opposite polarities. One has magnetic south north and another has magnetic south polarity. This is the pair. One sunspot is this one. This one is another sunspot in pair. Here we see the motion of sunspot because sun rotate on its axis. So this movie shows the motion of sunspot, how the sunspots are moving here. Sunspot have cyclic behavior and its cycle is 11 years. साइकिल होती है तो यहाँ देखिए दिखाई दे रहा है ये 1870 से हमने 2000 तक का डाटा लिया हुआ है तो ये 11 इयर्स की साइकिल दिखाई देती है यहाँ पर यहाँ से यहाँ 11 तो ये यहाँ स्टार्ट होनी शुरू हुई जब सन स्पॉट्स बहुत होते हैं सन स्पॉट्स सारी एक्टिविटीज का कारण होते हैं सन में तो here we see the solar maximum because the number of sun spots here we see the large number of sunspots here, and this is the minimum. So we call it solar minimum, and here, when the number of sunspots are much, then we call it this this solar maximum. This is the image taken by SDO, Solar Dynamic Observatory, launched by NASA in 2010. And the horizontal lines here show the latitude bands at every 10 degree north and south. Active regions. This is the active region. Active region is the part of the solar surface where the activities, here we see the activities of the sun. So this region where we see the activity, it is called active region. We see here various type of activities: flares, CMEs, plasma eating, flows, waves. Here we see a solar flare. Solar flares are violent explosion on the surface of the sun. And sudden, impulsive, intense, these are sudden, impulsive, intense, large-scale heating events. In a matter of just few minutes, they heat material too many millions of degrees. They occur near sunspots. Sunspots जब बनने शुरू हो जाते हैं, तो एक्टिविटीज सन में शुरू हो जाती है, और वो पीरियड एक्टिव सन का क्वाइट सन नहीं होता. क्वाइट सन जब होता है जब एक्टिविटी नहीं होती, जब एक्टिविटी होती है तो वो एक्टिव सन कहलाता है. तो सन स्पॉट सबसे पहले सन स्पॉट अपीयर्स होता है और फिर ये एक्टिविटी शुरू होती है, फ्लेयर्स होती हैं, कई सारी एक्टिविटीज होती है. Prominence. This is the prominence. This one. And here we see the Earth. In comparison to the size of this prominence, Earth is very small. So prominence are dense cloud of material suspended above the surface of the sun. Sun की surface के ऊपर जो ये material, sun का material दिखाई दे रहा है, इस तरीके से. Prominence is suspended होती है. Flares just explode हो जाती है. ये suspended material है, sun solar plasma.
They are attached to the sun.
हाँ. And their lifetime is from days to month. These are coronal lobes. We see various structures, tubular structure, slab structures, and streamers, flares. So this is the coronal lobe structure. This one. Plasma, because sun has a strong magnetic field, and plasma confines the plasma. Magnetic field confines the plasma along the magnetic field lines. So these are lobes, coronal lobes. MST waves we probe the plasma by wave because the waves carry information about the medium from which they travel. If the wave function is sine function, then the wave can be expressed as phi xt a sin omega t plus minus k as wave omega is frequency, k is wave number, a is amplitude. मेरे ख्याल से आप लोगों ने ये सब चीजें पढ़ी होंगी वेव के बारे में, मुझे ज्यादा बताने की जरूरत नहीं। MST wave is the result of interaction between electromagnetic field and magnetic conductive fluid, and these waves are important to study the dynamics and structure of the sun, but in particular solar interior and solar atmosphere, solar coronal heating, chromospheric heating, transport of plasma energy and momentum. He is the father of magnetohydrodynamics. Hans Elfman, Swedish mathematician. He in 1942 discovered the MST waves as an incompressible motion of perfectly conducting magnetized fluid. MST waves are of three types: Elfman waves, magnetoacoustic waves, fast and slow waves. Magnetic tension drive Elfman waves, while the magnetic pressure and plasma pressure drives magnetoacoustic waves. This is the dispersion relation of omega a square k square. Magnetoacoustic waves dispersion relation. Observation of MST waves. Here we see the photosphere and the wave travels from this is the photosphere, and wave travel due to the disturbance. Waves are generated here, and these waves carry energy from this photosphere and dump their energy in corona. So that's why that these energy is the temperature of the corona. MSD waves in weak magnetic field, MSD waves in strong magnetic field. This is the part of my research. I am not discussing. ये आप पढ़ा होगा, यदि फ्लूइड डायनामिक्स किसने पढ़ा है, फ्लूइड मैकेनिक्स पढ़ा है किसने, फ्लूइड मैकेनिक्स, तो वही डायनामिक्स को गवर्न करने वाली बेसिक इक्वेशन ही होती हैं, इक्वेशन ऑफ कंटिन्यूटी, इक्वेशन ऑफ मोशन, एनर्जी इक्वेशन, इंडक्शन इक्वेशन, इक्वेशन ऑफ स्टेट, क्योंकि यहाँ मैग्नेटिक फील्ड भी है और मैग्नेटिक फील्ड होने की वजह से इलेक्ट्रिक फील्ड भी है, तो मैक्सवेल इक्वेशन आ जाती है। ये बेसिक इक्वेशन मास कंजर्वेशन से आती है, इक्वेशन ऑफ कंटिन्यूटी, और इक्वेशन ऑफ कंटिन्यूटी momentum conservation of momentum se aati hai. These are the basic equations to govern the motion of the plasma, coronal plasma, and we have written here. These are the equations. We linearize here, then we apply the numerical scheme method to solve non-linear. These are the non-linear partial differential equation. We solve these equations by McCormick method numerically. ये मैं ज़्यादा बताना नहीं चाह रहा, इसके numerical simulation भी numerical simulation here. Temporal evolution of cut-off velocity ये सब research का part है. Another model. एक मैं मूवी दिखाना चाह रहा हूँ, एक क्योंकि मुझे 10 मिनट का टाइम जाएगा ना, तो अभी एक मूवी देखिए कैसे वहाँ इवेंट होती है, पूरी रिकॉर्ड किया गया वहाँ पर जो लूपिंग रेन है नासा ने, इसमें ही है। So mathematics, this is the part of applied mathematics. Here when you model, when you make a mathematical model, we will have partial differential equations, है ना? तो यहाँ जो फिजिकल जितने भी सिचुएशंस होती हैं या जो मॉडल्स होते हैं उनको हम मैथमेटिकल इक्वेशन में सॉल्व करते हैं, और मैथमेटिकल इक्वेशन क्या होती है, पार्शियल डिफरेंशियल इक्वेशन होती है। उन पार्शियल डिफरेंशियल इक्वेशन को मैथमेटिक्स में आप पढ़ा हुआ, उन पार्शियल डिफरेंशियल इक्वेशन को सॉल्व करके फिर आपको रिजल्ट बताना होता है कि वहां पर क्या वेलोसिटी है, क्या मैग्नेटिक फील्ड है, क्या टेम्परेचर है, कितनी हीट वहां पर प्रोड्यूस हो रही है, जो भी रीजन जिसमें आप बताना चाहें, वेरियस थिंग यू कैन डिस्कस हियर, तो बाय मेकिंग ए मॉडल। Applied mathematics.
Applied
This is the solar physics, plasma physics, solar physics. It is part of plasma physics, but we call it because it is concerned with solar sun, so we call it solar.
Particularly used for water, but here the hydro is used for some kind of plasma fluid.
Plasma, when you heat the gases at high temperature, gases ionized हो जाती है और उनका प्लाज्मा वो जब ionized हो जाते हैं इलेक्ट्रॉन हो जाते हैं तो वहाँ इलेक्ट्रिक मैग्नेटिक फील्ड आ जाता है फिजिक्स आ जाती है magnetic field, strong magnetic field.
What are the places where the generation of the
नीचे से जब एनर्जी आती है स्ट्रॉन्ग मैग्नेटिक फील्ड वो इनहिबिट करता है वो टेम्परेचर ये नीचे से आता है वो उससे वो डार्क स्पॉट पे लगता है टेम्परेचर
वो मैग्नेटिक फील्ड ज्यादा हो
इनोवेशन सभी होता है मैग्नेटिक फील्ड भी ग्रेविटी भी होती है पूरा मैग्नेटिक फील्ड भी ग्रेविटी भी टेम्परेचर सारी यूज होती है लेकिन ना आप इनोवेबिलिटी लोगे उतना ही मॉडल को डिस्कस करना मुश्किल है एयर इसी
कोई बात नहीं
नहीं ये पूरी एक्टिविटीज इस तरह की होती रहती है पूरी इवेंट ये रिकॉर्डेड इवेंट है आप जो स्टूडेंट्स हैं उनके लिए एक इंफॉर्मेशन है यहाँ पर ही नैनीताल में भी एक ऑब्जर्वेटरी है सोलर ऑब्जर्वेटरी आप यदि कोई वहाँ जाएं नैनीताल यदि विजिट करना हो तो ऑब्जर्वेटरी भी जाएं एरीज है तो वहाँ आपको वो पहले से मतलब आपको अपॉइंटमेंट लेना होगा बताना होगा एक टूर भी बना सकते हैं वहाँ एक चीज दिखा सकते हैं दैट्स ऑल
Thank you, sir. Thanks for your the vast information on the working of the sun, on the different layers of the sun. Now we will start our oral session. Just 1 minute, we are announcing the candidates. Okay, the first order talk is on paper ID PAMEA-111 Mr. Abhay Kumar, the title is Super Cyclicity Criteria for the Tensor Product of the Co-Semi Groups. He is connected in online mode. Mr. Abhay Kumar, are you connected?
Yes, I am connected.
आवाज खोल दी यार.
Are you able to share your screen? He has sent this or he is sharing the screen? Okay.
Am I audible? Let me check first.
It's not proper. If you can increase the volume, it will be okay.
Okay, I'm trying my level best. Okay.
Okay, please go ahead.
This kind of thing happens in online mode. Okay. Good afternoon, all. I'm Dr. Abhay Kumar from Department of Mathematics, HND Garhwal University, Srinagar, Uttarakhand. In this brief presentation, I'll just talk about only one result regarding supercyclicity criteria for the tensor product of C0 semigroups. If you are interested, then you can find me on Google by typing Abhay Kumar plus supercyclic. So here comes the definition. A C0 semigroup or a strongly continuous semigroup is a family of bounded linear operators acting on a Banach space satisfying the following three conditions. First two conditions are called semigroup property and third one is called strong continuity property of a semigroup. So once we have family of semigroup, then we define supercyclic. This supercyclic, a C0 semigroup on a Banach space X is called supercyclic if for some X in the space, this projective orbit is dense in X. Now somewhat stronger notion of this property, that is supercyclicity, is hypercyclicity, in which we don't have the scalars. Okay, now we come to a criteria. So if we have a family of C0 semigroups on Banach space, then this family, we say this family fulfills supercyclicity criteria if for every pair of non-empty open sets L and M in X and every zero neighborhood W in X, there exists some T and lambda in C such that these two sets are different from empty sets. Then stronger notion than supercyclicity criteria is recurrent supercyclicity criteria. So we say a strongly continuous semigroup on a separable Banach space satisfies recurrent supercyclicity criteria if for all non-empty open sets UV and zero neighborhood W, there exists lambda in C and there exists a constant L such that each interval contains an S with this property that these two sets are different from empty sets. Now, with the help of these two results, I come to my main result. Here, to simplify the notation, instead of semi-group, I am writing just TT. This denotes the semi-group. If TT and ST denote C0 semigroup on Banach spaces X and Y respectively, and suppose T satisfies recurrent supercyclicity criteria. And furthermore, alpha denotes uniform cross norm on X tensor Y. And if ST satisfies hypercyclicity criteria, then the semigroup on this space satisfies supercyclicity criteria, where this approximate bar denotes the completion of X tensor Y with respect to uniform cross norm. So this is my final result, which I wanted to show you. These are the references which I have used. If anyone is interested, then you can find me on Google to discuss furthermore. Any questions?
Okay, thank you, Abhay. Our next.
Yes. Thank you so much.
Thank you.
Are there any questions?
You are feeling some goal or something burden on you. That's too many speakers are coming here and saying something else. तो बच्चों मैं आप लोगों की लैंग्वेज में आपसे बात करने की कोशिश करूंगा विद योर परमिशन, क्योंकि मैं नहीं चाहता कि जो भी सेशन को इंटरेस्टिंग बने, इंटरेस्टिंग बनने की जगह बर्डन ना बने। तो इसमें केवल आप वैदिक मैथमेटिक्स के बारे में आपने बहुत कुछ पहले से सुना हुआ, कुछ इसमें नया हम करने की जा रहे हैं। केवल जो कैलकुलेशंस हम लोगों ने सीखी हुई है या आप लोगों ने सुनी हुई है, उन्हीं कैलकुलेशंस को बहुत इजी वे में, मतलब आप पढ़ोगे तो समझ में शायद थोड़ा देर में आए, यहाँ जब उसे प्रैक्टिकली आपको बताऊंगा तो प्रैक्टिकली करने में आपको थोड़ा मजा भी आएगा और बहुत इजी वे में हम करने की कोशिश करेंगे। और थोड़ा सा टाइम फाउंडेशन है, तो इसलिए टाइम फाउंडेशन मेरे साथ है। हालांकि अगर वैदिक मैथमेटिक्स को जब मैं कराने जाता हूँ तो मैं सोचता हूँ कि टाइम फाउंडेशन मेरे साथ ना हो, क्योंकि मैं जितनी देर में टाइम मुझे दिया हो उतनी देर में केवल आपसे कनेक्ट हो पाऊंगा, और जितनी देर कनेक्ट हो पाऊंगा उतनी देर में टाइम खत्म हो जाएगा, तो आगे की हम कैसे बात करेंगे। तो कोशिश करेंगे कि आपके साथ जल्दी जल्दी हम बात करें। तो अगर कुछ चीज गलत हो जाए तो आप लोगों से मैं पहले से सॉरी कह रहा हूँ। अगर आप लोगों को कुछ गलती सर ने गलत बोल दिया या गलत कर दिया तो पहले से ही आप लोगों से सॉरी कहना चाह रहा हूँ, ठीक है। तो सबसे पहले हम जैसे बोलते हैं, एक वर्ड होता है इम्पॉसिबल। आप लोगों ने बहुत बार सुना होगा इम्पॉसिबल, दैट इज इम्पॉसिबल। लेकिन जब कोई भी चीज बोलते हैं इम्पॉसिबल तो उसे हम बोलते हैं आई एम पॉसिबल, मेरे लिए सब कुछ पॉसिबल है। जैसे ही आपकी ये थिंकिंग चेंज होगी, ये मेरी गारंटी है, आपकी जैसी ये थिंकिंग चेंज होगी आपके लिए कुछ भी डिफिकल्ट नहीं होगा, क्योंकि अभी आप स्टूडेंट लाइफ में हैं, स्टूडेंट लाइफ में तो इसलिए आप इम्पॉसिबल भी सोच सकते हैं, लेकिन जैसे आप अपनी थिंकिंग को चेंज करेंगे सब कुछ आपके लिए पॉसिबल होगा। आपने लॉग टेबल का नाम सुना होगा, सुना है बच्चों ने? नहीं। तो आज से 5 साल पहले वो पूरी लॉग टेबल बाय हार्ट मुझे याद थी, लॉग एंटी लॉग दोनों याद थे। आप बोलते कि इसकी वैल्यू क्या है तो बता देता, या ये पूछते कि वैल्यू किसकी होगी तो वो भी बता सकता था। लेकिन एवरीथिंग डिपेंड्स ऑन प्रैक्टिस। उस समय वो पूरी लॉग टेबल केवल 12 मिनट के अंदर सुना सकता था, लेकिन प्रैक्टिस नहीं है तो छूट जाती है। तो आज इसमें क्या है, केवल प्रैक्टिस के साथ साथ आपके अपना कॉन्फिडेंस है, किताब अपने अंदर कॉन्फिडेंस रख सकते हैं। दूसरी बात हम कहते हैं, अभी इसका थोड़ा सा ब्रीफ ले लीजिए। चलिए मैं कैलकुलेशन पा लेता हूं, मैं कैलकुलेशन तो ये नंबर पार्टिसिपेंट बोलता है। तो बच्चों वही प्रॉब्लम थोड़ी सी हमारे सामने फिर से आई है, मैं बहुत तेजी से आपसे बात करने की कोशिश करूंगा। केवल पहले ब्रीफ बता देता हूं कि इसमें बहुत सारी टेक्निक्स हैं, सारी टेक्निक्स को हम कवर नहीं कर पाएंगे क्योंकि केवल हमारे पास 10 मिनट्स बचे हुए हैं। तो केवल मैं आप इसे पढ़ लीजिए, मैं आपको बता नहीं पाऊंगा क्या लिखा हुआ, मैं हालांकि बता सकता था लेकिन टाइम लगेगा। तो क्या इसको भी हम छोड़ देते, केवल ये दिखाना चाह रहे हैं कि कैलकुलेशन मैथमेटिक्स एक ऐसा सब्जेक्ट है जो जिसे हम कहते हैं फोबिया भी हो जाता है। मैथमेटिक्स हमारे फोबिया बन गया, किसी को बुखार आ गया, किसी को कुछ आ गया मैथमेटिक्स के नाम। तो कुछ बच्चे बहुत अच्छे होते हैं, अलजेब्रा में बहुत अच्छे होते हैं, लेकिन ग्राफ में थोड़े दिक्कत हो जाता है। ये बहुत छोटा सा एग्जांपल समझने के लिए दिया है, थोड़ा फंकी रूप में, कि एक जगह लिखा होगा हाफ हेयर कट, बंदा गया उसके आधे बाल काटे, आधे पैसे लेके आ गए, फिर वो दोबारा बाल कटवाने गया, फिर आधे बाल काटे, फिर आधे पैसे दिए। तो इस बंदे के बाल क्या कभी पूरे कट पाएंगे? अगर ये पूरे बाल कटवाने जाएगा तो इसके पूरे बाल कट सकते हैं इस सिचुएशन में। इसका मतलब क्या है, मैथमेटिक्स कभी खत्म नहीं होने वाला सब्जेक्ट है। आप जितना डीप जाते जाएंगे उतना डीप में आपको मैथमेटिक्स में गोता खाते जाएंगे। ये स्टेजेस है, जितनी स्टेज में आप घुसते जाएंगे उतनी स्टेजेस आपको खुलती जाएंगी। एक और छोटा सा एग्जांपल लेने की कोशिश कर रहे हैं, एक फल के रूप में लेने की कोशिश कर रहे हैं मैथ को समझने का। क्या कह रहे हैं कि वुमन इज इक्वल टू टाइम्स इनटू मनी। अब कहते हैं टाइम इज इक्वल टू मनी, टाइम हमारे लिए पैसा है, तो ये क्या होगा, वुमन इज इक्वल टू मनी इनटू मनी। लेकिन सामने लिखा है मनी इज द स्क्वायर रूट, मनी इज द रूट ऑफ ऑल प्रॉब्लम्स। इसे वुमन मनी इज इक्वल टू स्क्वायर रूट ऑफ प्रॉब्लम्स, तो वुमन इज इक्वल टू स्क्वायर रूट ऑफ प्रॉब्लम्स का स्क्वायर। सो आ गया वुमन इज इक्वल टू प्रॉब्लम के सॉल्व कर दिया मैथमेटिक्स से, वुमन इज द प्रॉब्लम। एक और छोटा सा एग्जांपल देख रहे हैं, बहुत तेजी से विस्तार, हम सीधे अपने कैलकुलेशन पे आएंगे। एक छोटा सा एग्जांपल, अगर हमने कहा कि मामा की वाइफ मामी है, तो चाचा की वाइफ क्या होगी? ये मैथमेटिक्स से प्रूव करने की हम कोशिश करेंगे, चाचा की वाइफ चाची होगी। अब देखते हैं, मामा अपॉन मामी इज इक्वल टू चाची अपॉन चाचा अपॉन एक्स। ठीक, अब x इज इक्वल टू चाचा इनटू मामी अपॉन मामा। हमने कट करना शुरू करा, m से m, a से a, m से m कट करा, a से a कट कर दिया, हमारे पास क्या होता, चाच इनटू y। तो x इज इक्वल टू चाची, चाचा की वाइफ होगी चाची। ये मैथमेटिकल कैलकुलेशन से प्रूव कर लिया हमने। अब बहुत देखो बेटा, बहुत शॉर्ट में चलते जा रहे हैं कि अब हम इसको थोड़ा ब्रीफली डिस्क्राइब नहीं कर रहे हैं, केवल ये बताना चाह रहे हैं कि ये कैलकुलेशन कोई नई नहीं है, ये हमारे अथर बेस से कैलकुलेशन लिखी हुई है, और जिसको श्री भारती तीर्थ कृष्ण महाराज ने एक मतलब संकलन कराया किसी पुस्तक के अंदर, जो आज हम पढ़ पा रहे हैं, वरना इसके बहुत सारी कैलकुलेशन थी जो हमारे सामने नहीं है। ये पूरी 16 सूत्रों पे आधारित है। आप केवल अगर 2 या 3 सूत्र भी याद कर लेंगे तो सारी कैलकुलेशन, बहुत सारी कैलकुलेशन आप कर सकते हैं। ये कहा जाता है वैदिक मैथमेटिक्स में, if you know the table about only up to the 5, then you can perform any calculation। केवल 5 तक की टेबल आपको अगर याद है तो कोई सी भी कैलकुलेशन आप परफॉर्म कर सकते हैं। ये 16 सूत्र, अगर संस्कृत में नाम तो लिखे तो फंसने भी शायद मजबूर हो जाए। एकाधिकेन प्रोवेन, एकयून प्रोवेन, या दुग्नम ताप दुग्ना योजनम च वर्गीकृता, इस तरह संस्कृत में इसके नाम है। अब इनके नाम की मीनिंग भी बहुत कुछ है, अलग अलग है, इसको बहुत जल्दी हम डिस्क्राइब नहीं कर सकते, तो थोड़ा सा हम इसको स्किप करते हुए चल रहे हैं पार्ट को। अब हम कह रहे हैं मेन फीचर्स ऑफ वैदिक मैथमेटिक्स, क्या हम कर सकते हैं, ये आप जल्दी से आप पढ़ लें। आपको एक तो सबसे पहले फ्लेक्सिबिलिटी मिलती है, मतलब आपको अगर टेबल नहीं याद है और वैदिक मैथमेटिक्स से आप कैलकुलेशन जानते हैं तो आप कहीं बीच से भी कैलकुलेशन को इजीली कर सकते हैं। दूसरा, सारी कैलकुलेशन आप ब्रेन के अंदर कर रहे हैं, देन यू विल नॉट हैव टू टेक द पेन एंड कॉपी। इसका मतलब आपकी मेमोरी पावर भी बहुत ज्यादा एनहांस होने वाली है। और इसके अलावा क्या है, इंक्रीज द मेंटल एबिलिटी, और साथ में क्या एक्यूरेसी भी इसके अंदर बढ़ती है। आपकी नॉर्मल कैलकुलेशन से करेंगे और इस कैलकुलेशन से करेंगे तो आपकी एक्यूरेसी भी बढ़ेगी। चलिए एक टेक्निक, बहुत इजी वाली टेक्निक हम देखते हैं। हम करना चाह रहे हैं कि लर्निंग द टेबल विद द फिंगर्स। अभी हमने क्या कर दिया, आप केवल अपनी फिंगर्स को सामने अपने रख लें, इस तरह से सारी फिंगर्स को आप इस तरह से अपने सामने रख लें, और नंबरिंग जैसे बताते जा रहे हैं कि यहाँ से 6 7 8 9 10, ऐसे 6 7 8 9 10, क्लियर है? देखते जाते जैसे जैसे बताता जा रहा है। अब आपको टेबल में देखना है कि 8 8 का 64 हमें याद है। अब ये फिंगर से हम कैसे बताएंगे 8 8 का 64 होगा। मैं शायद आवाज पीछे तक आ रही है, एम आई ऑडिबल? तो मैंने ये कहा कि 8 8 जा 6 7 8, ये मेरी 8 फिंगर है, ऐसे इसकी लिया मैंने 6 7 8 फिंगर इसके लिए, दोनों आपस में कनेक्ट कर, ठीक है? 8 8 जा निकालना। अब ये थोड़ा लगेगा कि सर ये तो बहुत देर लग रही है करने में, लेकिन जब आप प्रैक्टिस हो जाएगी तो आपको जब देर नहीं लगेगी।
अब मैंने क्या करा, ये सारी फिंगर फोल्ड कर ली, मेरे को लेफ्ट पार्ट निकालना है, मुझे 8 8 64 का लेफ्ट पार्ट निकालना है। तो मैं क्या करूंगा, ये काउंट करूंगा कितनी फिंगर हुई, ये फिंगर 1 2 3 4 5 6, लेफ्ट पार्ट मेरा हो गया 6, अगेन 1 2 3, जहां तक हमारे टच हो रही है, ऐसे 3 फिंगर इधर टच हो रही है, तो हमारा लेफ्ट पार्ट हो गया 6। उसके बाद निकालना है मुझे राइट पार्ट। राइट पार्ट के लिए जो बची हुई फिंगर है इनकी मल्टीप्लाई कर लेंगे, 2 2 जा 4, तो 8 8 जा 64 हो गया। क्लियर है? टाइम वेस्ट होगा, बहुत जल्दी जल्दी करते हैं। अब मैं ये देखो, ये टेक्निक जो है कुछ नई नहीं है, अगर आप करोगे तो आपको सब मिलेगा। अब मैं बताता हूँ 9 की टेबल। 9 की टेबल फिंगर से कैसे करते हैं, 1 2 3 4 5 6 7 8 9 10, मैंने नाम दे दिया, ठीक है। सारी फिंगर्स को 1 से स्टार्ट करा, 10 तक नाम दे दिया। मैंने कहा 9 बन जा 9, मैंने फर्स्ट फिंगर को फोल्ड करा, फर्स्ट फिंगर को फोल्ड करा। अब दो पार्ट होते हैं, इस फिंगर के लेफ्ट में कितनी फिंगर है, अरे इसके लेफ्ट में कितनी है 0, और इसके राइट में कितनी है 9, तो 9 बन जा 9, 9 2 जा। अब देखेंगे लेफ्ट में कितनी फिंगर है 1, और राइट में कितनी फिंगर है, तो 9 2 जा 18, 9 3 जा 27, 9 4 जा, इजीली आ रहा है, कोई दिक्कत इसमें? तो आगे देखते हैं हम टेक्निक। ये वाली जो 9 की टेबल है उसकी टेक्निक आ रही है, देखते जाएंगे, इससे भी हम देखते जाएंगे। अब जो है 12 की टेबल को हम कैसे याद रख सकते हैं, 12 की टेबल कैसे तो याद होगी, लेकिन जिसे याद नहीं होती उसको हम कैसे कर सकते हैं। जैसे कि आपने कहा सर 12 5 का मुझे डायरेक्ट याद करना है, आजकल के बच्चे जो होते हैं मोस्टली बच्चे अब तो कर रहे हैं वो पूरी टेबल याद करने पहले 12 1 जा 1 5 2 जा 24 ऐसे करके तब 12 5 तक पहुंचते हैं। मैं ये कहता हूं कि जिससे मल्टीप्लाई करनी है, जिससे मल्टीप्लाई करनी है 12 5 जो मैंने कहा या 12 4 जो मैंने कहा, वो मैं राइट पार्ट में एज इट इज लिखूंगा, ठीक है। 12 4 जो मैं अगर मुझे करना है तो राइट लेफ्ट पार्ट में वो 4 एज इट इज लिखूंगा, और राइट पार्ट में क्या करूंगा, उस 4 की 2 से मल्टीप्लाई करके लिखूंगा, 12 4 जा 40। क्लियर हुई बात? नहीं देखते हैं, चलो इससे अभी देखते हैं इससे कैसे 12 4 जा की हम बात कर रहे थे। देखो ये 12 4 जा निकालना है, तो मैंने क्या कहा, इस 4 को मैं राइट लेफ्ट पार्ट में ऐसे लिखूंगा, ठीक है, और राइट पार्ट में क्या करूंगा, इस 4 की 2 से मल्टीप्लाई करके लिखूंगा, 12 4 जा 48, 12 6 जा आपको निकालना है, तो इसमें एक कैरी भी आ जाता है साथ में, वो कैरी को मैं फिर एंड पॉइंट उसको ऐड करके लिखूंगा, 6 और 1 7, 12 6 जा 70। क्लियर है? ये मैं बहुत जल्दी कर रहा हूं सर, ये तो मैं और तेज कर लेता हूं सर, ये कोई थोड़ा कर लेता हूं, क्योंकि बहुत सारी लंबी लाइन है। चलिए एक लास्ट टेक्निक है, एक लास्ट टेक्निक देखते हैं, ठीक है सर। मार्कर पेन हो जाए, वो यहाँ से वैसी कैलकुलेशन देखते हैं, वो बहुत बच्चों बहुत तेजी से करेंगे, आगे मार्कर आगे बहुत तेजी से करेंगे कैलकुलेशन को। अब 5 डिजिट का एक नंबर हम आप लोग बताएं बहुत तेजी से, 7 8 अब अगर इसकी आपको मल्टीप्लाई करनी हो तो कितनी देर में कर लेंगे? इसकी मल्टीप्लाई अगर आपको करनी हो तो कितनी देर में आप आंसर दे सकते हैं? चलिए देखते हैं कितनी देर में आंसर आता है। ये इसका आंसर है। और एडिशन को सीख लेते, क्योंकि तो अब टाइम खत्म है, ये लास्ट में बता रहा हूं मैं आपको। ये टेक्निक सीख लेते, अगर ये टेक्निक आप किसी के साथ में कहें, बोले 5 डिजिट का 2 नंबर था, 5 डिजिट का मुझे दे और कितनी देर में आप आंसर बताते हैं, तो वो देखते इस आंसर को 2 पार्ट में डिवाइड कर लेते हैं। ठीक है, यहाँ पे क्या करते हैं, ऊपर वाले में से एक माइनस कर देते और बाकी जो ये आंसर आया पूरा, इन सबको 9 में से माइनस करके लिख देते। 9 7 by 2 9 8 by 1 9 2 by 7 9 6 by 3 9 4 by 5। तो ये कैलकुलेशन कभी भी आप कैलकुलेट करोगे, आप कितनी भी लंबी कैलकुलेशन ले लो, 10 डिजिट का भी नंबर ले लो तो मुश्किल से 10 सेकंड में आंसर आप लिख दोगे इसका।
तो तभी संभव है जब 99 वाली
वो सब कैलकुलेशन और बहुत सारी यहाँ पे बता नहीं सकता चाहिए
वैदिक मैथमेटिक्स।
हाँ, तो बच्चों कुछ भी गलती हुई हो तो उसके लिए क्षमा प्रार्थी। बहुत तेजी से कोशिश करिए आप लोगों के साथ शेयर करने की। आप लोगों की कोई क्वेरी अगर हो कुछ आप लोग नया जानना चाहते हैं इसमें, तो आप मुझसे पूछ सकते हैं। आप यस बेटा बच्चों एप्टीट्यूड भी पढ़ा देंगे। आप मेरा फोन नंबर नोट कर लो, कभी आपको कैलकुलेशन की जरूरत पड़े तो वीडियो मीट पे हम कर लेंगे इसको। ठीक है, आप नंबर नोट कर लो 890 92 8878। ठीक है सर। माय नेम इज डॉक्टर मनोज कुमार अग्रवाल और कभी अगर फ्यूचर में आपसे कनेक्ट होने का मौका मिलेगा तो आपको मेमोरी टेक्निक्स भी सिखाएंगे। ठीक है बच्चों, थैंक यू वेरी मच।
थैंक यू वेरी मच मनोज सर। मनोज सर
अनुज के भाई हो ना।
थैंक यू वेरी मच मनोज सर। Session was very much interesting and Abhinav sir has promised that he will call her specially for a separate session to the NSS. So very soon you will have an interaction with Abhinav sir for a longer time. But now we are going to call our third speaker. It's a ID 130. The name is Prabhuntha Kumpulam Vigai R. Topic is computational technique of the stochastic model for the rainfall. Are you connected?
Yes, sir. Yes, sir. Yes, sir.
Shubham. Shubham, are you connected?
Yes, sir. Yes, sir.
Yeah. So. Please share your screen. Yeah, go ahead. You have 5 minutes. 5
Good evening.
minutes. We have a lot of questions.
Sir, sir, visible, sir? Hello, sir. Visible?
Yes, ma'am.
Okay, sir. Good evening to all. Sir, I'm Sugandha Kundalam Bihai, Tamil Nadu Agriculture University, Assistant Professor of Mathematics, Tamil Nadu Agriculture University. Today we discuss about the computational techniques of the fuzzy stochastical model for rainfall forecasting. So to analyze the agroclimatic parameter of the district, Trichy district, to develop a model to predict southwest monsoon and northwest monsoons rains in Trichy district. Now to test the applicability of the fuzzy statistical model, rainfall forecasting in Trichy district 2004 to 2010. So these are some definition of the basic definition. Let y of t equal to etc 0, 1, 2, etc. a subset of real numbers be the universe of discourse by which fuzzy sets fj of t are defined. If f of t is a collection of f1 of t, f2 of t, etc., then f of t is called a fuzzy time series defined on y of t. Next definition, suppose f of t minus 1 equal to ai and f of t equal to aj. A fuzzy logical relationship is defined as ai to aj, where ai is named as the left-hand side of the fuzzy logical relationship and aj is the right-hand side of the fuzzy logical relationship. So what are the computational techniques we used in this paper? First one, collect the historical data. Second, we define the universe of discourse and intervals. The intervals, we define what is the minimum value and the maximum value. If you select, then you take the interval. Here 2004 to 2010 rainfall data, I will take u equal to minimum rainfall data 379.79 and the maximum rainfall data 1163.59. This is the maximum and minimum. But I will take the interval u equal to 300 to 1200. Then we take the partitioned by several intervals. It may be 300 to 100, 150, many intervals we have to separate. Then what is the third and fourth? We define the fuzzy sets based on the intervals and linguistic variables. Next one, fuzzify the historical data. Next, determine the fuzzy logical relationship for all fuzzified data. Then group fuzzy logical relationship as in steps 6, having the same the left hand side and the derive the fuzzy logical relationship group, connected the group. What is the last one? We're computing the predicted rainfall. So first step, collect the historical data. The second one, we select the minimum and the maximum intervals. Then we get this is a fuzzy logical relationship group. We define the. I will take the 14 district, 14 black in Trichy district. I have to choose this rainfall data. This is a group of fuzzy logical relationship groups we combined. That's meaning the fuzzy logical relation and the fuzzy logical relationship groups. So then this is the fuzzy logical relationship actual data and I will compare the different methods. Here I will compare the 4 different methods. So here is this actual one. This is the method 1. Method 1 means 16 interval I have used to. This is 6 intervals. Then third method T-Shatur. The fourth method is song method. This is the 4 different method. So in the predict value is fuzzy. Here the fuzzy stochastical model. Which one is the first method is on predicted one. So in this paper, we have proposed a new method. This is a method 1 for handling the forecasting problems based on fuzzy time series in the stochastical model, where the data of the historical enrollment of the Trichy district rainfall data are adapted to the illustrate to the forecasting process. We have also shown the method 1 is more efficient than the other methods. Furthermore, the linear trend line and R-square values is smaller than the another 3 methods. The forecasting ability is better than the traditional forecasting methods of Chen and T-Shatur et al. in the area of forecasting average rainfall. It has been successfully implemented to the forecasting of the annual average rainfall district of the Trichy. Thank you, sir.
So, from the audience, is there any query?
Sir.
Kota Bhati. The ID is 182 and the identity.
Yes, sir.
Hello, sir. Hello, sir. What? Any suggestions, sir?
बंद कर देगा आप।
Yes, sir. Yes, sir. I am here, sir. Can you hear me, sir? Yes, sir. Respected professors and all eminent people present here, a very good afternoon. Today, I'm here to present my paper, The Iterative System of Elliptic Equations in an Annulus and its Positive Radial Solutions. I am Bhatta Bharati, a PhD research scholar from Andhra University, working under the guidance of Professor K. Rajan Prasad, sir. I'm also working as an assistant professor in Gayatri Vidya Parishad College of Engineering for Women, Visakhapatnam. So this is the basic elliptic equation we are considering. In the introduction part, let us discuss what works are done related to this equation. So Dong and we established the existence of the radial solutions for the following nonlinear elliptic equations with the gradient terms in annular domains. I'm sorry, I'm not reading these equations because it will take much time. So I'm skipping this. Paddy and Gareth and Kanogia considered the following elliptic boundary value problems in an annulus. The equation is mentioned, the second one. R. Kajikia and Eco established the existence of positive radial solutions for a semi-positone elliptic equation of the form, which is the last one you can see. And finally, Sun and Wang studied the positive radial solutions for the nonlinear elliptic equations of the form, which is there on the top set of equations. So these are the previous works. Now our present problem is the one which is highlighted here. So here we establish the existence of positive radial solutions of the iterative system of nonlinear elliptic equation in an annulus, which is given by sir. Sir. Delta uj plus p of mod x gj of uj plus 1 equals to 0, which is defined in the annulus region r1 less than mod x less than r2 with one of the following sets of boundary conditions. So here we will be considering any one of the following sets of boundary conditions. Now we'll be converting
that our equation into another convenient differential equations by writing r equals to mod x. Then the iterative system reduces to the study of positive solutions to the following system, which is given by uj double dash of r plus n minus 1 by r into uj dash plus p of r into that the first equation which was mentioned, which is further can be transformed into another differential equation given by vj double dash of y plus r power 2 into n minus 1 of y p of r of y gj of vj plus 1 of y equals to 0. So here vl plus 1 is v1, which shows that it is an iterative one, and a equals to minus of integral r1 to r2 tau per 1 minus n d tau. It can further be transformed into the following system of boundary value problem, which will be convenient for us to set a kernel and its bounds. It is given by wj omega j double dash of tau plus q of tau gj of omega j plus 1 of tau, which equals to 0, where the tau value lies in between 0 and 1, subject to the boundary conditions alpha omega j of 0 minus beta omega j dash of 0 equals to 0. And the other condition is gamma omega j of 1 plus delta omega j dash of 1 equals to 0. Now here, throughout our paper, we will be assuming the conditions that the first condition is gj, the function gj is continuous from left closed to 0 comma plus infinity, which one is the right closed, and qi is continuous from closed interval 0 comma 1 to 0 comma infinity, and qi does not vanish identically on any subinterval of closed interval 0 comma 1, and it may have the singularities on 0 comma 1 by 2. And here we are defining the extended real numbers gj 0 equal and gj infinity, which are defined as gj not equals to limit as extends to 0 plus gj of x by x, and gj infinity is defined as limit as extends to infinity gj of x by x for 1 less than or equals to j less than or equals to L. Now we'll be entering into the, yes sir? Sorry sir, it's not clear.
It has
Sir? Yes, sir, I'll end up it, sir, in 5 minutes. So here we'll be using, sir? Sir, your voice is it's resounding, sir. I'm not able to hear you properly. Can I continue, sir? Thank you, sir. So now the kernel and its bounds. For this, we have the basic lemma where the boundary value problem, which is our main problem, is converted into the boundary value problem of this notation. So now this will have a unique solution, w1 of tau equals to integral 0 to 1 chi of tau comma s v of s ds. So where the kernel kernel is given by 1 by d into, so this expression is given here. Now the second lemma, it shows the kernel, the properties of the kernel, what properties it will have. The first one, chi of tau comma is always non-negative and continuous. Chi of tau comma s is less than or equals to chi of s comma s, which next, there exists C belongs to open interval 0 comma 1 by 2 such that zeta of C chi of s comma s is always less than or equals to chi of tau comma s. This proof is a simple proof. Now here are the few assumptions for our work. From the lemma, the solution, the L tuple, will be a solution when omega 1 of t is defined like this, integral 0 to 1 chi of tau comma s. So that expression. In general, so what is omega j of t, what is omega 1 of t, it is given here, and we denote a Banach space here, B, with the norm omega equals to maximum of norm omega of tau. For C belongs to open interval 0 comma 1 by 2, and the cone PC is a subset of B is defined by This one. So here we have defined a Banach space with a norm and a cone. Now for any W1 belongs to PC, we define an operator T from PC to B like this. And this is one lemma which shows that this T, the operator T which we have defined now from PC to PC is completely continuous. Now, for the positive radial solutions, this is the basic theorem that we are using, Krasnoselski's fixed point theorem. Let epsilon be a cone in a Banach space X.
You have
Yes, sir, I'll conclude, sir. So this is the basic theorem that we are using. And next, these are the theorems using the Krasnoselski's fixed point theorem. This is one theorem, and there is another theorem which shows that the Krasnoselski's fixed point theorem conditions are satisfied, and hence the problem can have a solution. Yes, sir. Thank you, sir. Any queries, sir? Thank you, sir. Sir? Thank you, sir. Thank you, sir.
Dr. Pramod Kumar, the ID is 116. Dr. Pramod Kumar.
Okay, sir. Okay, sir.
Dr. Pramod,
sir, my slide visible, sir.
Yeah.
Okay. Okay, shall I start, sir? Good afternoon, everybody. Okay, good afternoon, everybody. The title of my paper presentation is Computing Two-Distance Sourcing Number of Graphs with Large Diameter. I am working as Assistant Professor of Mathematics, Government Polytechnic College, Kerala. Presentation. Overview. This is abstract. In this paper, we compute the two-distance sourcing number Z2DG of some graphs with large diameter. Also, we find the two-distance sourcing number of some complement graphs. These are preliminary definitions. Color change rule. Let G be a graph with each vertex colored either black or white. If a black colored vertex has exactly one white colored two-distance neighbor, then change the color of the white vertex to black. Next definition, derived coloring. Given a coloring of G, the derived coloring is the result of applying the color change rule until no more changes are possible. Now we define a two-distance forcing set. A two-distance forcing set of a graph G is a subset Z2D of vertices of G such that if initially the vertices in Z2D are colored black and the remaining vertices are colored white, the derived coloring of G is all black. Now we define the two-distance forcing number. The two-distance forcing number Z2D of G is the minimum of cardinality of Z2D over all two-distance forcing sets Z2D subsets of V of G. For example, consider the graph G depicted in the figure. In the figure, the vertices P, Q, U, V are the two-distance neighbors of the vertex R. Under definition, let U be an arbitrary vertex in G. The two-distance degree of U is defined as the number of vertices which are at a distance at most 2 from U, including the vertex U. The two-distance degree of the vertex U is denoted by degree 2D of U. Under definition, consider the two-distance degree of all vertices in a graph G. The minimum among them is called the minimum two-distance degree of the graph G, and it is denoted by small delta 2D of G. Similarly, the maximum among them is called the maximum two-distance degree of the graph G. The maximum two-distance degree of G is denoted by capital delta 2D of G. Now we find the two-distance forcing number of some graphs. Theorems. Let G be a connected graph of order n greater than or equal to 3. Then two-distance forcing number of G always greater than or equal to small delta 2D of G minus 1. Another theorem, let G be a connected graph of order n greater than or equal to 3. Then the zero forcing number is always greater than the two-distance forcing number of G. Okay. Next theorem, the two-distance forcing number of the shadow graph D2 Pn of what, sir? of path Pn where n greater than or equal to 3 is n plus 2. Then we consider the middle graph. The 0th number of the middle graph is obtained as n. Next, we consider the triangular snake graph with at least 2 triangles. Then the 0th number is obtained as k plus 2, where k is the number of the triangles in G. Then we consider the sunlight graph Sn. Then the two distance source number of sunlight graph is obtained as 4 if n equal to 3 and if n greater than or equal to 4. If the graph is a comet graph, then the two distance source number is obtained as m plus 1. If G is the n span graph, then the 0th number is obtained as 4. Let G be a connected graph with the maximum degree 2, then the two distance source number is obtained as 2 or 4. Let G be the generalized friendship graph FPK, where P greater than or equal to 5 and K greater than or equal to P, then the two distance source number is obtained as 3K. Now we compute two distance source number of routed product of graphs. Let G be the routed product Pn Pm of a path Pn and the routed path Pm, routed with the pendant vectors of Pm, where n greater than or equal to 2, m greater than or equal to 4. Then the two distance source number is less than or equal to 2 into n minus 1. Another router product, let G denotes the router product Pn Cm of a path Pn and the router cycle Cm, where n greater than or equal to 2, m greater than or equal to 5. Then the two distance source number is always less than or equal to 3n. Let G be the graph representing the router product Cn Pt of a cycle Cn. Okay. On the router path Pt with the pendant vectors of Pt, where n t greater than or equal to 4, then the two distance source number is always less than or equal to 2n minus 4. Let G be the router product Cn Cm of a cycle.
Dr. Pramod,
Okay.
it has been 5 minutes. You are expected to
Okay, just 2 minutes, sir. Just 2 minutes.
Yeah.
Okay. Let G denotes the square graph of a path Pn where n greater than or equal to 5, then the two distance source number is obtained as 4. Let G be the square graph of a cycle Cn n greater than or equal to 9, then the two distance source number is obtained as 8. Let G be the splitting graph of a path Pn where n greater than or equal to 4, then the two distance source number is obtained as n. Now we obtain the two distance source of Cartesian product of graphs. These are two theorems. We skip by reading due to the shortage of time, sir. Another two theorems. Let G represent the circular ladder graph Cn Cartesian product K2. Then the result is shown as like this. The two distance source number of complement of graphs. These are the two theorems. This is my conclusion, sir. References. Thank you, sir.
Thank you, Dr. Pramod.
Okay, sir.
Is there any query in this session?
Okay, sir.
Okay.
Okay.
There is no query, so thank you for your presentation.
Okay, sir.
We'll go for our next presentation, that is Mr. Ajit Kumar Yadav, ID 113. Topic is recent development in the writer design conjecture a survey. So, Mr. Ajit Kumar Yadav, are you connected? Mr. Ajit Kumar Yadav. Mr. Manoj Kumar, ID 114. Mr. Manoj Kumar, are you connected?
मनोज कुमार भी नहीं है सर.
Can I present, sir? Can I present?
What's your name?
रश्मि यादव.
What's your name?
रश्मि यादव सर. रश्मि यादव.
Me Yadav.
What's your ID?
ID PAME-126.
126. There are many presenters before you. If you have any other, we'll call you. Otherwise, we will.
So my one is 121.
Yeah. So if you have not any emergency, we'll go by the serial number.
Hello,
Sir,
sir.
your voice not clear. Please again.
Okay, the next presenter, Mr. Deepak Singh. Mr. Deepak Singh, ID 115.
Yes, sir.
Yeah, Deepak, are you connected? ID 115.
Yes, sir.
Okay, so we'll go in the predefined series. The title is analysis of pentagram daily problem about sectional generalized Deninder wavelets. Deepak, you have 5 minutes for your presentation.
Okay, sir.
Now please share your screen.
Good afternoon, all of you. Myself Deepak Singh and from Department of Mathematics and Statistics from Gurukul Kangadi, Haridwar, Uttarakhand. My paper title is analysis of analysis of pantograph model. For delay problem about a fractional generalized Legendre wavelets. There are some introduction. According to this title, we have here fractional and about Legendre wavelet, which is a generalized form. So fractional calculus is recent wavelet theory is an emerging field of engineering science and mathematical research, and wavelet analysis is an appropriate mathematical tool which has been extensively used in a quantum field theory, signal analysis, image digital processing, numerical analysis, and many other fields. There are numerous work on the wavelet scheme, which yes, sir. Okay, sir. So here are fractional calculus has become a more popular and emerging field of mathematics due to its extending application.
F5, please.
In a modern theory, in this problem, which I have been used here, there are a problem of fractal fractional type, which has been get by the modern theory of a fractal fractional operator, which combines the theory of a fractal operator, and a fractional operator has been studied as a convolution of a power law. Also, it is a Mittag-Leffler law and an exponential law with the fractal operator. In a variant mathematical model, differential equation of an integer order and non-integer order play a crucial role in solving the various type of problems. The new concept of a fractal fractional operator, and there are lots of application in various areas. And we introduce here fractal fractional model of a pantograph delay differential equation by using the concept of fractal fractional differential operator and then find their approximate solution through fractional generalized Legendre wavelet. In the work, a numerical approach based on the fractal fractional integral operational matrix. Yes, sir.
As you have 5 minutes and you have 15 slides.
Yes, sir. Yes, sir.
Just go for the key points of each slide. You are reading the slide, that will take much more time. And we have to stop.
These are basic similarities.
Just focus on the key point of one particular slide and please avoid reading.
Hello. Hello. Is there I'm audible, sir?
Yeah, sure, please.
Yes, sir. These are basic primitives. First one is a fractal fractional derivative operator. If the function ft is continuous and a fractal differentiable on this open interval a comma b with order beta, then the capriccio fractional derivative of this function with order alpha is defined by this equation number 1. Here alpha denotes the fractional order and beta denotes the fractal order, and the integral has a power law kernel. And here in this equation 1, this terms is defined by this relation. Now second one is a fractal fractional integral operator. Similarly, if the function f is continuous and fractal differentiable on this interval of with order beta, then the capriccio fractional integral of a function ft with order alpha is defined by this equation number 2. Here the integral has a power law kernel, and this the relation between these two integral and differential fractal fractional operator is given by the relation by equation number 3. And here, whenever we use here alpha equal to beta equal to 1, then the equation number 1 and 2 will become the just ordinary type. Now, in this method, we approximate the function by using this relation where h is an x-square integral function in this interval 0, 1 and can be extended by this relation where ht is approximated by summations n equal to 1 to infinity and m equal to 0 to infinity e and m and this function psi, where e and m is a wavelet coefficient with respect to this wavelet, and the wavelet coefficient are also obtained by this relation, where this term wn theta nu mu of t is an wavelet function for this given wavelet. Now, problem. We have here fractional model of a pantograph delay differential equation. Here we consider a following integer order pantograph differential equation by this equation number 5. This is an integer type. So we convert this type of problem in a fractional form, which can be obtained by using the above operator. Yes. Yes, sir. Okay, okay, sir. Okay. Okay, sir. This is our problem. And I have taken a particular example for this problem in which I have fixed here the value of A and B. So I have get this problem number 7 with initial condition this one. I have fixed here alpha equal to beta equal to 1 and mu equal to 0 and find the solution of different values of theta, and which are given by this table. Here I have taken this result for theta equal to 0.3, theta equal to 0.5, and theta equal to 0.7. And in this next table, theta equal to 0.9, theta equal to 0.99, and theta equal to 1. These are the solutions. Now, concluding this paper, we introduce a model of pantograph delay differential equation for fractal fractional type, then fractal fractional integral operational matrix of fractional generalized Legendre wavelet and collocation method has been introduced for an approximate solution. We can solve both linear and non-linear type problem by this technique. So these are some references. And thank you. Yes, sir.
Any query from Mr. Deepak? Okay, and there's a suggestion, Deepak, and keep the content small and the font size large for presentation. Because of the presentation, the slides view line should be readable at one glance. For the presentation is a suggestion for you. Thank you for your presentation. The next presenter is Mr. Nitesh Kumar, ID 117.
Okay, sir. Thank you, sir.
Nitesh,
yes.
ID 117. Are you connected? Mr. Nitesh Kumar, ID 117. Not seems to be connected, so we'll go for the next presenter. Mr. Gaurav Agarwal, ID 118.
Yes, sir.
Yeah,
yes, sir. Presenting. Yes, sir. Thank you, sir. Yes, sir.
भैया फोन करके बिना बैठे मेरे को करवा कर रहे
Okay, Gaurav, you have 5 minutes for your presentation. Please share your screen.
इसकी मीटिंग है थोड़ा
Okay, sir. Deepak, please stop your sharing. Good evening, all. Am I audible?
Yes, sir.
Good evening, all. My name is Gaurav Agrawal, research scholar from Gurukul Kangadi University, Haridwar. I'm pursuing my research under the supervision of Dr. Nidhi Handa, Department of Mathematics Statistics, Gurukul Kangadi, Haridwar, and co-supervisor Dr. Omkar Lal Srivastava, Department of Mathematics, Government Kamla Rathi, Girls PG College, Rajnandgaon, Chhattisgarh. My research topic is a brief study of Bhavana and Chakrawal algorithm. Content, these are the contents: abstract, introduction, Bhavana, Chakrawal, conclusion, and references. Abstract. This paper deals with the method of Bhavana and Chakrawal algorithm for solving journal quadratic indeterminate equation called Varg Prakriti in ancient India. Brahmgupta was the first who gave method of Bhavana. After this, Jaydev and Shripati laid the foundation for Chakrawal algorithm, while Bhaskar II and Narayan Pandit made further extension and gave clarification with example in his Ganit Kumudi. We analyze the hypothesis and proofs of the algorithm, take some example present in earlier text, and compare results by putting them in tabular form. Introduction. A polynomial equation in two or more variable with integer coefficient that is desired to have integer rational roots is called an indeterminate equation. Brahmgupta was the first to give the method of Bhavana, the law of composition for solving quadratic indeterminate equation is major work Brahmsput Siddhant, composed in 6th to 8th century. After him, Acharya Jaydev and Bhaskar II gave the Chakrawal algorithm for the integer solution of indeterminate equation of the type nx square plus k equal to y square, and especially the equation nx square plus 1 equal to y square. Narayan Pandit made further extension and gave clarification with example. This paper attempts to illuminate the method used by Brahmgupta, Jaydev, and Bhaskar II to solve the indeterminate equation. Bhavana. Principle of composition. From the classical age of Indian mathematics and astronomy, Brahmgupta was one of the greatest mathematicians who contributed efficiently. Brahmgupta is credited for giving the law of composition, which is used for solving indeterminate equation. From Brahmsput Siddhant, we found the following preposition. One of these 1008 words used for binary composition. Mulam dvida istu vargad gunat istu yuta vinam cha adya gunat guna saha antya ghatin kritam antyam vrajvadhikam prathamam prakshep shep badhyatullah prakshep paso thakarte mule prakshepe rupe. Mathematical interpretation of this shloka: n equal to multiplier x pratham moolam y second root k interpolator, and the final result is x. If x1 y1 k1 x2 y2 k2 are the two solution, then x1 y2 plus 2 comma n x1 x2 plus minus y1 y2 comma k1 k2 is another solution. Theorem Brahmgupta Bhavana. This result is also proved here. Brahmgupta identity. This is the Brahmgupta identity. Y1 is square minus nx square, y2 square minus nxt square, and this on. This is the another theorem present in BSS Brahmsput Siddhanto Brahmgupta for solving nx square plus 1 equal to y square. We take this example 92x square plus 1 equal to y square, and finally we found this the integer solution of the equation 92x square plus 1 equal to y square. This is 120,1151. Next method is Chakrawal. Brahmgupta method Bhavana is no doubt interesting but limited and based on some arbitrary choices. The Chakrawal process, an improved method, was first given by Jaydev and Shripati in the 11th century, followed by Bhaskar II and Narayan Pandit. Jaydev's Chakrawal method. The Sundari Uday Divakar's commentary on the Laghu Bhaskari of Bhaskar first, cured from Jaydev's work. This was brought to our notice by Shukla. These are the steps Jaydev used for solving indeterminate equation, and these steps, in the last step, we can see nx square plus 1 equal to y square, and we get the solution x is equal to a and y equal to a by following these steps. We show some, we take an example n equal to 58. It's mean 58x square plus 1 equal to y square. This equation is solved by using Chakraval method. These are some solutions, results. Our conclusion. The study of indeterminate equation, especially the study of equation nx square plus 1 equal to y square, played an important role in the evolution of classical algebra and number theory in ancient India as well as in modern Europe. After performing the technique and analyzing all the results, we conclude that Brahmgupta Bhavar and Jaydev and Bhaskar second Chakraval method provided a fertile ground for the development of solution of the equation nx square plus 1 equal to y square for all non-square positive values of n in minimum number of steps as compared to the modern European methods given by Euler and Lagrange. Euler and Lagrange gave method of simple continued fraction. These are some references that I followed for preparing this paper.
Nice presentation, Gaurav.
Thank you.
It's a nice attempt to bring forward our ancient mathematical techniques to the modern era. So, any query with Gaurav? There is no query, Gaurav. So, thank you for presentation. Our next presenter.
Can I stop sharing my screen?
Yeah, sure.
Thank you. Thank you, sir. Thank you.
Our next presenter is Ms. Rashi Arya, ID 138. The topic is the literature review of machine repairable planning system. Rashi, you have 5 minutes for the topic.
Can I present? My name is Rashi Arya. I am a research scholar of mathematics department in T. Thakur Mahavir University, and I am here to present the topic literature review on machine repairing system. So first we have to know what is queuing theory. The queuing theory is a study of movement of pupils, objects, or information through a line. So here it's abstract. The current article goal is to provide a historical overview of several significant research papers concerning queues in machine system. The repair process may be done earlier of failure or can be done after the failure. Failure means breakdown, machine breakdown. The failure of a machine could cause a considerable loss in production, income, or reputation. In order to provide a true catalog or understanding the research in the repairable field domain, a careful list of books and research papers is also prepared in addition to reference on cues in this is we have categorized the pertinent literature into categories based on the methodological consideration and modeling consideration. In this literature review, our research team conduct on how different goods and managed items such as computer modules, aircraft, engine, motor, manufacturing lines, communication network, electric fan, with the increasing production of industry repairable problems in machines now get more important. Hence, the maintenance facility must be modified so that the machine can be fixed right away and the process can proceed except being significantly disrupted. A thorough list of books and survey papers is complicated in the bibliography to provide a true understanding of use in a machine system. This description can assist researchers and the beginners in their exploration of twin notions and related areas from the very basic of the most complex details. So here is the literature review of paper 1. So in paper 1, author have designed a support system for repairable items. He used a mathematical model to minimize the problem and then apply stochastic process model, Poisson failure process, and multi-unit, multi-location design model, resulting in a total system cost was reduced. In paper 2, author have discussed about the problem that is particularly challenging.
Good.
So these are the references of this literature. Any questions?
Have you used any particular system for applying trading theory?
Some machine.
How to
repair machine? How to repair machine? सब वो तो electrical जो वहाँ पे हीट में लोग होता है तो वो रिपेयर करते हैं। पर्टिकुलर टाइप ऑफ मशीन नहीं ले सकते हम सर सारी मशीन को लेंगे सर हम इसमें ये देख रहे हैं कि हम मशीन्स को हम जब रिपेयर करते हैं तो वो दो तरीके से होते हैं एक तो वो फेलियर होने ब्रेकडाउन होने से पहले और एक ब्रेकडाउन होने के बाद तो हम हमारा मॉडल ये है
Okay, thank you for the nice presentation.
Thank you.
So next speaker ID 119 is the AMEA-2022.
Sir, yes, sir. Yes, sir. Okay, sir. I started.
You have 5 minutes.
Okay, sir.
AMEA-2022.
Yes, sir. Audible?
Yeah.
Okay, sir. Good morning. Good afternoon. I am Jnana Arakyam. This is scholar of Department of Mathematics, Madurai Kamarajar University, Madurai. My topic is I study on beta open set in a topological spaces. The abstracts of a beta open set and the beta closed set and introduce this study topological properties of beta limit points, derived sets, and the interior beta closure sets, and also we discuss these introductions. The notions of alpha open set was introduced by Nechester since when it was widely investigated in several literatures. Now I shifted to alpha open set to beta open set. That is, if A is subset A is contained in interior closure of A, and also basically the complement of beta open set and the beta closure sets are also discussed in this my topic. And the definitions of alpha open set: a subset of a topological space x comma tau is said to be alpha open if A is subset of interior closed interior of A. Also, we know that the complement of your alpha open set is alpha closed sets. the limit point and the derived sets. Yeah, let A be a subset of a space X, a point X is belongs to set, which is a limit point, and the condition is union intersection of A minus X is not equal to empty set. In view of the a subset A is also a beta closure set if only if A equal to closure of beta of A. That is the conditions. We explained some examples. Tau a topological space, pi x A C D be a topological on a set. T power alpha is alpha open set and beta is beta open sets. We conclude that. Let A be a subset of a topological space x comma t. A point x belongs to is said to be beta limit point. The beta limit point we defined about these conditions satisfy. G belongs to t beta, x belongs to G implies G intersection of A negative of x is not equal to empty set. The collection of set is a beta limit points. The collection of all beta limit points is also called a derived set of beta sets. That is denoted by beta sets. Note that a subset A of x, a point x is not a pre-limit point, and those point for examples, beta derived set and also then we have the two theorems of the closed sets beta and alpha open sets. Features of reference to we extended the theorem of beta semi-open sets, semi-closed sets also in future my work also. This is the conclusion. Beta semi-open, beta semi-intersection, also expand the functions in beta semi-open and beta open software. These are my references. Thank you, sir. Thank you. Thank you, sir. Okay, sir. Yes, sir. Thank you, sir. Okay, sir. Thank you, sir.
I think that there is no query, Mr. Alakriam, so thank you for your presentation. Our
Okay.
next speaker is Mr. Hemant Kumar, ID 120.
Okay, sir.
Mr. Hemant Kumar, ID 120.
Yes, sir, I am here.
Yeah. And the topic is choose the one among various available options using the technique of operational research. So you have 5 minutes for your presentation.
Yes, sir, I am trying to open it in my mobile. I am unable to open it in my mobile. I will try to open it in my laptop. Please give me some time. 15 minutes I will do.
Yeah, Hemant, if you are not able to share your screen, we'll go for the secretary and issue. Is there any issue sharing your screen? Okay, Hemant, did you resolve your issue? We'll go for the next candidate. ID 121, Mr. Krishnan Verma.
Yes, sir. Am I audible?
Yeah. Please share your screen. You have 5 minutes for presentation.
Okay, sir. Is my screen visible?
Yeah.
Okay.
Now it's visible.
Is it visible now?
Yeah, it's visible.
Okay, sir. Good evening, everyone. I am Krishnan Verma from Department of Mathematics, Dibrugad University, and I am going to give a presentation on my work, Effect of Chemical Reaction on Heat and Mass Transport Process on MSD Nanofluid Flow, past a vertical elongating surface considering slip conditions at the boundary. Outline of a presentation consists of definitions, formulation of problem, method of solution, results and discussion, conclusion, and references. First of all, I would like to define nanofluid. So nanofluid is a special collateral suspensions of micro-sized particles referred to as nanoparticles in a base fluid. Nanoparticles basically are made of metals, carbon nanotubes, carbides, etc. While base fluids are water, oil, ethylene glycol, etc. I will skip the rest of the part for time restricted issue. So let me come to the mathematical formulation of the problem. So we have considered a vertical surface in a two-dimensional system and a flow of nanofluid past a permeable surface. Here we have considered it to be permeable. It is as it is shown in this figure. X-axis is taken along the plate and y-axis is taken normal to it. We have assumed the fluid to be incompressible and flow to be steady. The surface is assumed to be stretching in an exponential manner. The temperature at the surface of the plate is Tw and volume fraction of nanoparticles is Cw. In the direction perpendicular to the surface, a variable magnetic field Bx is applied. Induced magnetic field opposes comparatively less strength than the applied magnetic field, and so it is neglected. Further, it is assumed that there is thermal equilibrium between the nanoparticles and the fluid. In accordance with the work of Haley and Augiche, we have incorporated slip effects of velocity, thermal, and nanoparticles concentration at a solid boundary. Governing equation of problem is given by equation 1, which represents the equation of continuity. Equation 2 represents the equation of momentum. Here, the important effects that we have incorporated in equation 2 are the MSD effect represented by this term. This term is due to porous medium. This two term is due to buoyancy effect, and this is due to inertia force. Equation 3 represents the energy transfer equation. Here, important effects are these two terms is due to combined effect of Brownian motion and thermophoresis. This is due to viscous dissipation effect, and this is due to thermal radiation. Equation 4 is a mass transfer equation. This term is due to chemical reaction effect, and this is due to thermophoresis. Here, tau represents the ratio of heat capacity of nanoparticles in the base fluid. Here, B, alpha, and K are defined as follows. Here, B is the magnetic field, alpha is thermal diffusibility, and K is permeability of the porous medium. So, boundary conditions are given in equation 5 and 6. So the velocity in x direction is represented here. Here, this is due to the slip effect. Along V, that is in y direction, we have considered suction that is taking place here. Vw is defined here as follows. Temperature Tw plus this term is due to the thermal slip, and this is due to the concentration slip. And far away from the plate, the velocity is assumed to be 0. Temperature and concentration will be equal to the free stream temperature and concentration of the fluid. So radiation is given by equation 8. Here, T to the 4 expanded Taylor series is represented here. We have introduced the similarity transformations to in order to convert our governing equation dimensionless form, that is given by equation 9. And with the help of this stream function psi, our equation of continuity is satisfied automatically. The rest of the equation, that is equation 2 to 4, are and the rest of the equations are given by equation 10 to 12, and the boundary conditions are transformed to equation 13 and 14. These are the constants obtained in the above equation. Here is Prandtl number, S is Schmidt number, and so on. So I would like to skip the method of solution. We have actually used a MATLAB Solver BV4C to obtain the numerical solution. I will directly come to the solution. So figure 2 and 3 represents the impact of thermophoresis parameter on fluid temperature and nanoparticle volume distribution. So we can see with the increase in thermophoresis parameter, fluid temperature as well as the volume fraction nanoparticles increases. Figure 4 and 5, you can see the impact of Brownian motion parameter on temperature and nanoparticle volume concentration. So we can see with the increase in Brownian motion parameter, fluid temperature increases, whereas nanoparticles concentration decreases. In figure 6, we can see with the increase in radiation parameter, fluid temperature grows, while in equation 7, also we can see with the increase in Eckert number, fluid temperature rises. Where Eckert number here, it represents the impact of viscous dissipation on the fluid, and we can see the impact of viscous dissipation on the fluid helps in the rise of the fluid temperature. In figure 8, we can see with the increase in chemical reaction parameter, the concentration of the nanoparticles decreases. Actually, we know chemical reaction parameter directly affects the mass diffusion rate, and here the decrease in concentration just implies that mass diffusion is taking away from the surface of the plate. In figure 9, we can see with the increase in velocity slip parameter, velocity of the fluid decreases. And in figure 10, we can see with the increase in thermal slip parameter, the fluid decreases. And in figure 11, we can see this in the particle concentration increases with the increase in concentration slip parameter. So we have made a comparison of our work with the work of Haley and Ogichi to check our validity of a result. And here, and we have made a comparison for different values of Prandtl number. Yes, sir.
You have completed your time. 7.
Okay, sir. Okay, sir. Okay. And here you can see it's a wonderful match. And in this table, we have compared heat and Nusselt number, Sarut number, and skin coefficient for different parameters. These are the conclusions which I have discussed in the graphs, and these are references which I have used for the preparation of the work. Thank you.
Thank you, Krishnandan, for your presentation. Any queries, Krishnandan? Okay, Krishnandan, there is no query. Thanks for your presentation. We'll
Okay,
go
sir.
for the next presenter. Is Mr. Lalit Mohan, ID 122. Lalit. Not connected. Next, Ms. Madhu, ID 123. Ms. Madhu, just Madhu. Madhu, ID 123. Okay, next, Ms. Mansa Kotwani, ID 124. Mansa Kotwani.
माइक की जरूरत नहीं है, नहीं बैठ जाओ, नहीं दिख रहा ऑनलाइन कौन है वरना ऑफलाइन माइक की जरूरत नहीं।
Mansa Kotwani, ID 124.
कौन कौन है कौन नहीं ऑनलाइन।
Next, Ms. Rashmi Yadav, ID 126. Ms. Rashmi Yadav,
Yes,
ID 126.
yes, sir. I'm audible.
A Vedic approaching division.
Yes, sir.
Yeah. You have, ma'am, you have 5 minutes for your presentation. Please share your screen.
Yes, sir. My screen is visible.
Yeah.
Thank you. My topic is a Vedic approach in division. That's my abstract introduction. Direct मैं directly process की बात करूंगी जी.
Okay, okay. Actually, it's not clearly visible. The slides are small. Okay, please go ahead.
Okay.
Better you come directly to the method of
हाँ,
division.
मैं डायरेक्टली डिवीजन की बात करूंगी मेथड की. इसमें हम जो बेस के नियर नंबर होता है 1000 या 100 या 10, तो ये सारे बेस नंबर्स होते हैं. इसके डिवीजन के लिए हम निकलम मेथड को अप्लाई करते हैं कि जब इसमें बेस से नंबर ज्यादा अबव होता है. लाइक आप देख रहे हैं डिवीजन प्रॉब्लम, मुझे करना है 102 को डिवाइड 9 से, तो मैंने डिवीजन पार्ट में 1 लिया क्योंकि जो 9 है वो बेस से हमारा एक कम है, और जो नंबर है तो मैंने रिमाइंडर पार्ट में 2 लिखा है एंड क्वेश्चन पार्ट में 10, बिकॉज रिमाइंडर पार्ट में हम उतने डिजिट लिखते हैं जितने हमारे डिविजन पार्ट में है. उसके बाद हम 1 को एज इट इज लिख देंगे क्वेश्चन में, और इस 1 की मल्टीप्लाई हम डिविजन पार्ट के 1 से करेंगे जो आपको मेरे वर्किंग प्रोसेस में दिख रहा होगा, और उस 1 को हम 0 के नीचे लिखेंगे एंड 0 1 को ऐड करेंगे और वो डायरेक्ट आपका क्वेश्चन पार्ट में आ जाएगा. और फिर जो क्वेश्चन पार्ट में आपका सेकंड 1 आया है तो उसके 1 की मल्टीप्लाई आप डिविजन पार्ट में करेंगे 1 into 1 एंड ये आपका रिमाइंडर पार्ट में लिखा जाएगा एंड 2 + 1 = 3. तो इस तरह जो आपके बड़े से बड़े नंबर होंगे तो आपको डिवीजन करने के लिए उनको कन्वर्ट करना होगा बेस नंबर में. लाइक आपको 99 की डिवाइड करनी है तो 99 आपका 100 बेस में है और वो कितना कम आपका आएगा 0 1. वहां भी इस प्रोसेस को आप 0 1 से करेंगे तो वो आपका वैदिक मैथमेटिक्स से बहुत ईजी आ जाता है. जब आप इसी को अपने नॉर्मल मैथमेटिक्स में करते हैं तो वो आपको टफ पड़ता है. ये आपकी बेस मेथड के लिए है. अगर आप जनरल किसी और भी नंबर को डिवीजन करना चाहते हैं उसके लिए ऊर्ध्वतिर्यक मेथड है. एक मेथड है हमारा परावर्ती योजित मेथड. ये आपका जो बेस से अबव नंबर होता है, मैंने निकलम मेथड में बेस से बिलो लिया, ये बेस से अबव है. लाइक आपको 2357 का डिवाइड करना है 11 से तो आप डिवीजन पार्ट में 1 लिखेंगे क्योंकि ये बेस से 1 ज्यादा है, और रिमाइंडर पार्ट में सेम एज आपका 1 डिजिट आएगा और प्रोसेस बिल्कुल सेम रहेगी। इसमें क्या होगा, आपका ट्रांसपोज हो जाता है नंबर का। ट्रांसपोज कि आपका अगर पॉजिटिव है तो उसको हम नेगेटिव कर देते हैं। तो हमने 2 into 1 किया, हमें 2 मिला और उसका ट्रांसपोज करके हमने 3 के नीचे लिख दिया, तो 3 minus 2 1। फिर 1 into 1 किया, 1 का ट्रांसपोज करके लिखा, तो 5 minus 1 is equals to 4। इसी तरह 4 into 1 एंड आपको मिल गया 3। 7 4 minus 3, तो आपका क्वेश्चन में 2 1 4 एंड रिमाइंडर पार्ट में आपका 3 आ जाता है। इसकी मेथोडोलॉजी ये है कि स्टडी लर्निंग है, और जब इससे हम मेथड्स को करते हैं तो जो हमारे मेंटली प्रेशर रहता है डिवीजन का, वो हमारा कम हो जाता है। और इसके बेस पे मैंने एक एक्शन रिसर्च किया था स्माइल नेशनल महिला पीजी कॉलेज में ग्रेजुएशन के स्टूडेंट पे, और उनकी उस पे मैंने ये उनको मॉडर्न मेथड से टाइम कराया जो वो बचपन से सीखते आ रहे हैं, और ये मैंने उन्हें एक दिन आधे घंटे में सिखाया। उसमें आप टाइम देख सकते हैं कि उन्होंने वैदिक में कितना कम टाइम लिया, और मॉडर्न से जो कि वो कम से कम 10 साल तो उन्होंने प्रैक्टिस की होगी इसकी, उसमें उन्होंने कितना ज्यादा टाइम लिया। और उसके बाद उनका एक्यूरेसी चार्ट कि जिस मेथड को वो बचपन से करते आ रहे हैं, इवन 10 ईयर प्रैक्टिस के बाद भी उसमें उनकी एक्यूरेसी नहीं है, और अगर हम वैदिक से करते हैं तो उनका जो एक्यूरेसी है वो 100% राइट है। तो थैंक यू सर।
Thanks, Ms. Rashmi Yadav, for enlightening us on the Vedic methods for division, as well as you have applied the theory and see the results in the graduation students. So it's nice to see that.
Yes, sir.
Well, thanks. Our next speaker is ID 127, Sachin Kumar Agrawal. Sachin Kumar Agrawal, ID 127. Don't seems to be connected. So next is ID 128, Shabnam Jasrotia.
Yes, sir.
Yeah, Shabnam, you are connected. Okay.
Yes, sir.
So please share your screen. The title is the solution of Buck's equation by accelerated homotopy perturbation transformation method.
Yes, sir.
Please share your screen, Shabnam. We have 5 minutes for your presentation.
Yes, sir. Yes, sir. So it is visible?
It's in the process of visibility. Yeah, it's visible.
Okay. Good evening, everyone. Myself, Shabnam Jasrotia, Research Scholar in Department of Mathematics from Lovely Professional University, Fagbara, Jalandhar. Today here I am presenting my research paper titled The Solution of Burgers Equation by Accelerated Homotopy Perturbation Transformation Method. Abstract. In this current study, a hybrid algorithm called Accelerated Homotopy Perturbation Transformation Method is used to solve the nonlinear Burgers equation by combining the well-known semi-analytical approach homotopy perturbation method and an integral transform called the Laplace transform. The outcome obtained by accelerated homotopy perturbation transformation method are contrast with the outcome that have already been published in the literature. In the introduction, nonlinear phenomena are crucial in applied mathematics, physics, and engineering problem because each parameter varies due to variety of variable. Although researchers in recent past have developed various methods based on semi-analytical techniques for exact or approximate solution of these equations, such as His homotopy perturbation method, homotopy perturbation transformation method, variation iteration method. Here we employ a new type of His polynomial called accelerated His polynomial. We speed up the method's convergence rate to getting the approximate series solution of the nonlinear Burgers equation. We apply accelerated homotopy perturbation transformation method, a novel type of semi-analytical methodology. The outcome of this method are then compared with the exact solutions that have previously been published in the literature. Burgers equation. Burgers equation is one of the fundamental equation in fluid mechanics. Burgers equation describe the interaction between diffusion and convection process. The conventional version of Burgers equation is given by ut plus u into ux is equals to v into v xx, where t is greater than 0. Definition and properties. Laplace transformation. The Laplace transform is the transformation which convert the time domain function into the frequency domain function. Defined by L of ut is equals to integration 0 to infinity e raised to power minus st ut dt. Here is some properties of Laplace transformation. To demonstrate the following concept of this method, we consider the general nonlinear non-homogeneous partial differential equation with the initial condition. Then we apply the Laplace transformation method to the equation first, and then we apply the properties of the Laplace transformation, then inverse Laplace transform. After that, we apply the homotopy perturbation transformation method. Then we compare the coefficients of the like power of the p, and then after that we can find the solution in the series of solution. After that, then we apply this on the example. My first example is Burgers equation. That is, first Burgers equation is ut plus u into ux is equals to u xx with initial condition ux0 is equals to x, and where uxt is the exact solution. After solving the series of solution, then we compare it by using the surface graph and the line graph. Figure 1 represents the surface graph of the exact solution when t is equals to 0.1, and figure 2 represent the surface graph of the accelerated homotopy perturbation method when t equals to 0.1. They are similar. Figure 3 represent the line graph of the exact solution and the method which we apply. Both are give the same result, which is shown in the figure 3rd. Similarly, we apply Burgers equation with a different initial condition, that is 1 minus 2 upon x, with the exact solution 1 minus 2 upon x minus t. Figure 4 represent the surface graph of the exact solution of equation 2nd, and the figure 5 represent the surface graph of the method which I used. So they are, and figure 6 represent the line graph. They are similar. So it is clear from this, they are accurate solution. Conclusion: in present study, semi-analytical techniques, that is accelerated homotopy perturbation transformation method, is used to solve Burgers equation. The solution obtained from accelerated homotopy perturbation transformation method is compared with the exact solution that is already available in the literature. Approximate solution is obtained by comparing both the solution is same. The only difference that exists is accelerated homotopy perturbation transform method give the result in the less terms, hence making this more efficient and less time consuming. The above findings were obtained with the help of the Mathematica software. These are the references which I used in my research. Thank you.
मैंने कर दिया था. Shabnam, which software did you use to draw the graph?
Yes, sir.
Which software did you use to draw the graph?
Software, sir. Mathematica software.
Oh, for graph also.
Yes, sir. For line graph and surface graph, both, sir. Both graphs.
Okay, okay. Thanks for your presentation.
Yes,
Any
sir.
query?
Thank you so much.
Since there is no query, so thanks for your presentation. We'll go for the next talk.
Thank you so much, sir.
ID 129, Mr. Manoj Kumar. Mr. Manoj Kumar, ID 129. Seems not to be connected, so we go for the next. Mr. Vinod Yadav, ID 131.
Yes, sir. I'm here, sir.
Yeah, Vinod.
Yes, sir.
Yeah, please share your screen. We have 5 minutes.
Okay, 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 okay.
लिखा है. अच्छा. Lack of thermal equilibrium effects on convection in a
Yes, sir.
saturated porous media with an Alice fluid.
Yes, sir.
Devang.
Yes. Good evening to all. This is Vinod, research scholar, working under the guidance of Dr. Raghunath sir, Assistant Professor, Department of Mathematics, Davangere University, Davangere. Firstly, I would like to say thanks to AMEA organized committee as well as my guide for giving me this opportunity to present the paper here. Let's start the presentation. Lack of thermal equilibrium, effects on convection in a saturated porous media with an Alice fluid. This is abstract. the manifestation of local thermal non-equilibrium temperatures and a constant horizontal pressure gradient on the onset of thermal convection in an Ellis fluid saturated porous medium is studied analytically. The imposed constant pressure gradient reinforced in achieving the onset of convection is to be oscillatory. Here, eigenvalue problem is solved analytically and the condition for the onset of convection is obtained. It is found that instability sets in as oscillatory mode contrary to the manifestation of stationary convection in Newtonian fluid saturated porous layer. The effects of local thermal non-equilibrium and Ellis fluid parameters are discussed here. The solution is constructed analytically. The associated results are described via graphical representation. Here are some applications. The analysis of thermal instability in porous media saturated by viscous non-Newtonian fluids is of great importance for its application in the field of engineering, biomedical, and geophysical areas. Examples are the extraction of crude oils, either onshore or offshore, blood perfusion in biological tissue, as well as design of food industry process. The main advantages of Ellis model is that it predicts the Newtonian behavior at small shear stresses and power law behavior at large shear stresses. It is the geometry of the problem. Here, the figure consists of horizontal layer of porous media of thickness D and saturated with an incompressible Ellis fluid. The flow in porous media is governed by modified Darcy law and the porous medium is in local thermal non-equilibrium described by a two temperature model. Here, two temperature means one is for solid and another for liquid. Here, these are the governing equations, continuity equation, velocity. 3 and 4 are the temperature equation for one is for solid and another for is liquid. These are the boundary condition which I have used. These are all the non-dimensional parameters I am used in that equation. Then obtain simplified equations are, these are all the equations. Now, linear instability, take the divergence of the above equations, we get this and apply and boundary conditions also will changes. Then to investigate the instability of the basic state, the all basic states are put at 0. For this, now in basic state, I want to disturb that state by means of perturbations. These are all the equation 13 is the perturbation equation. Now these are all the final nonlinear equations. Now I am going to solve these equations. These equation 14 to 16 forms an eigenvalue problem. For this, I am choosing these solutions are chi as a cos pi y, theta as a2 sin pi y, and a3 sin pi y. I am going to solve this in a form of determinant. So now here I am going to solve a Rayleigh number. So that means R. This is that number. Through this, I can say the system is stable or unstable through this Rayleigh number. These are all the graphs for the variation of neutral Darcy Rayleigh number with respect to wave number. Here, that figure 1 shows the effect of increasing the Ellis number omega, and porosity is to decrease the region of stability because of increase in pressure gradient and decrease in the stability effect of interface heat transfer effect. For figure 2, variation of oscillatory critical thermal Darcy Rayleigh number with respect to H, that is interface heat transfer. Here, minimum and maximum value of H, RC remains independent. RC means oscillatory critical Darcy number. Figure 3, variation of oscillatory critical value number with respect to wave number. The critical wave number decreases with increasing the value of omega, and hence its effect is to increase the size of convection cells, while it increasing with increasing the power law index. Figure 4, variation of critical frequency. Here, the critical frequency increases with increasing in Ellis number, and gamma, which it decreases with increasing in N, that is power law index. Here, the conclusion, the indication of local thermal non-equilibrium, temperatures, and constant horizontal pressure gradient on the onset of thermal convection in an Ellis saturated porous media is studied analytically. The effect of increasing Darcy-Ellis number and the Ellis power law index is to be diminish the size of the convection cells respectively. The Darcy-Ellis number and the Ellis power law index exhibit the increasing and decreasing influence on the critical frequency. These are all the references I have used. And finally, thank you. Thank you all.
Okay. Thanks, Vinod. Thanks
Okay,
for the
thank you.
presentation.
Okay, thank you, sir.
Our next speaker is Mr. Vinod Bhatia, ID 132. Mr. Vinod Bhatia, ID 132. Vinod, are you connected? No. We'll go for the next candidate. Mr. CN Dhone, ID 133. Mr. CN Dhone, ID 133. The next one. Mr. Harinder Kumar, ID 134. Harinder Kumar, ID 134. Mr. Sushil Shukla, ID 142. Mr. Sushil Shukla, ID 142.
Yes, sir, I am present. Yes, sir, I am present.
Okay, Dr. Sushil Shukla.
Yes, sir.
Sushil ji.
Yes, sir.
You have 5 minutes for your presentation.
Yes, sir.
The title is confirm a screen of on a light like hypersurfaces of Kan-Motsu space form. Sushil ji, you have 5 minutes for your presentation.
Yes, sir.
Please share your screen.
Is my screen visible, sir? Is my screen visible? Sir, can you hear me? Sir, can you hear me? Sir, can you hear me? Is my screen visible? Is my document visible, sir? Sir, is my document visible?
Yes.
Yes, visible.
Respected chairman of the session and participants, the topic of my paper is on conformal screen on light-like hypersurfaces of Kan-Motsu space form. The object of present paper is to study the properties of conformal screen on light-like hypersurfaces of Kan-Motsu space form with LM type connection. Before giving the details, here I want to describe some basics. A linear connection delta bar on a semi-Riemannian manifold Mg is called a LM type connection if delta bar and its torsion tensor T bar satisfies 1.1 and 1.2, where L and M are two smooth functions on M bar and J is a tensor field of type 1,1 and theta is a one form associated with a smooth unit vector field J, which is called the characteristic vector field M bar given by theta x bar equal to G bar x bar J. And by direct calculation, it can be seen that delta bar and delta are related by 1.3, where delta is the Levi-Civita connection of a semi-Riemannian manifold M bar G bar. Actually, LM type connection is the generalization of different type of connection by giving particular values of L and M. For example, if we consider L equal to 1, M equal to 0, then the above connection delta bar becomes a semi-symmetric, non-metric connection, and the notion of semi-symmetric non-metric connection was on a Riemannian manifold was introduced by Agassi and Chafle and later studied by several authors. In case we take L equal to 0 and M equal to 1, then the above connection becomes a non-metric phi symmetric connection such that phi x bar y bar equal to g bar j x bar y bar. And the notion of non-metric phi symmetric connection was introduced by Jean. In case we take L equal to 1 and M equal to 0 in the first equation and L equal to 0 and M equal to 1 in the second equation, then the above connection delta bar becomes a quarter symmetric non-metric connection. And the notion of quarter symmetric non-metric connection was introduced by Golab and then studied by Sen Gupta and Biswas and Ahmad Hasib. In case we take LM both 0 in the first equation and L equal to 0 and M equal to 1 in the second equation, then the connection delta bar becomes a quarter symmetric metric connection, and the notion of quarter symmetric metric connection was introduced by Yano and Imai. In case we take LM both 0 in first equation and L equal to 1, M equal to 0 in the second equation, then the above connection becomes a semi-symmetric metric connection, and the notion of semi-symmetric metric connection was introduced by Haydn. These are some basic definitions. What is almost contact manifold? These are defined here by 2.1, 2.2, 2.3, and these are some further calculations. These are calculations which are used further. In third section, we have do calculation on LM type connection. These are 3.1, 3.2, 3.3. And one theorem is let M be a light-like hypersurface of Kane-Motsu manifold M bar be the LM type connection such that
Dr. Sushil, you have consumed 5 minutes. Please conclude your presentation.
Yes, sir. Then B is symmetric if and only if M equal to 0. This is the proof, and these are further calculations. This is definition of Kane-Motsu space form, and these are simple calculations which are used in the main theorem. And this is one definition, and a light-like hypersurface M is said to be screen conformal if there exists a non-vanishing smooth function phi on U such that this 4.7 is satisfied. Main result of the paper is let M be a light-like hypersurface of Kane-Motsu space form M bar C with a LM type connection such that J is tangent to M. Then if M is screen conformal, then C plus 1 equal to 0. And this is the proof. This is the proof. And these are some references. Thank you, sir.
Thanks, sir. In which journal this work is published?
Sir, this is your format to take the paper. So I converted in your format.
Okay, sir. Okay, this is for the conference proceeding. Okay, thanks for your presentation.
Thank you, sir.
Our next attender is Mr. Ankit Kumar, ID 151. Next speaker, Ankit Kumar, ID 151. Is there anyone who has not presented his or her work? Is there anyone who is left to present his or her work?
120 serial.
Anyone connected online who has not presented his or her work? His name is skipped or he was not present at the time of calling.
Serial number 120.
I am naming all the candidates whose presentation is left. Ajit Kumar Yadav, ID 113. Manoj Kumar, ID 114.
She's raising it.
Okay, Stuti Gupta, you are raising hand. What's your ID?
139.
Stuti तो गोपाल की स्टूडेंट है।
कल डिपार्टमेंट में रिसर्च स्कॉलर। एक मिनट।
139. Hello.
Hi, Stuti.
Am I
Please
audible?
share your screen.
Yes, sir. Yes, sir. Doing that. Sir, is it visible?
Yeah, it's visible. You have 5 minutes for your presentation.
Yes, sir. Thank you so much for giving me this opportunity to present my idea in the National Conference on Ancient Mathematics and its Emerging Areas 2022. My topic for the day is prevalence of infertility and its associated risk factors across urban millennials. I, Stuti Gupta, research scholar, Department of Mathematics, Tirthankar Mahavir University, under the guidance of Dr. Gopal Kumar Gupta. Content, background, Indian scenario, problem definition, and etc. I'll start with the background. Now, infertility, is it natural or man-made? Infertility is a state of reproductive health where bearing children is impossible without medical or clinical intervention. Infertility is a serious health issue worldwide that has profound socioeconomic and health implications on both the individual and society, affecting approximately 8 to 10% of the couples worldwide. Of 60 to 80 million couples suffering from infertility every year worldwide, probably between 15 and 20 million are in India alone. According to a report by the WHO, 1 in every 4 couples in developing countries is affected by infertility. The magnitude of the problem calls for urgent action, particularly when the majority of cases of infertility is avoidable. Infertility is a worldwide public health agenda affecting an individual's personal, social, and economic life and the family as a whole. Infertility has become a personal and public health issue in India with a double-digit increase. Aside from this social stigma, infertility causes a lot of financial and emotional stress for couples. India is a country with a wide diversity, and there is diversity in customs, traditions, quality of living, accessibility to healthcare systems, and also climatic conditions. Due to these factors, infertility rate varies widely not only among various states, but also within the same region. Due to lifestyle changes, rapid urbanization, job pressures, vehicular pollution, postponing parenthood, and the presence of various environmental pressures, the prevalence of infertility has increased significantly and has become the third most serious disease after cancer and cardiovascular diseases. More than natural, the problem is rendered man-made for millennial population. The triggered infertility comprises of the deliberate human action or inaction to delay, deviate, or constrain the fertility, ultimately transforming the fertility prospects onto infertility. The triggered infertility is rather a new research concept and has drawn tremendous research attention. Now, these are some current news in newspapers where Indian scenario has been reflected about infertility. So these are some of the news where infertility is rising in India, probably, but doctors can't be sure. The rising problem of infertility in India affects around 10% to 15% of the married couples and etc. World, and these are some of the other newspaper articles which have already been published. Now, problem definition. Yes, sir.
Can you come to the conclusion, please?
Yes, sir, I'll do that. So these are my four main important factors under proximal, which is individual aspects, vocational, career-driven, and health and drugs. And under distal, these are stress aspects, contingent, and sexual and reproductive health communications. So I have done a regression model on the factors, and this came out to be my regression model, where fertility is my dependent variable, and independent variables have taken mortality, birth rate, death rate,
contraceptive and life expectancy. This all data is worked on the secondary data taken from WHO and UN websites. And conclusion, the research hence concludes that there is significant impact of millennia-derived individual, vocational, career-driven, health-related, stress-derived, contingent, as well as sexual and reproductive malpractices on triggering the state of infertility. The bioecological approach underlines the philosophy of influences that impact the overall shaping of the infertility in men and women from Indian perspective and enhances our understanding of the phenomena. The millennials' individual deficiencies, incompetencies, lack of information, contextual occupational requirements, stress, rising digitalization, and aspiration will always interfere with fertility determination. So this concludes my work for today. And please, any questions?
Thank you, Sruti. I would like to ask a question. This is Dr. Alok Bhela from Department of Mathematics.
Yes, sir.
And my simple question is, why are you using the regression model only? Is there any specific reason for that, or?
So this was a very basic study which I have just done so that I conclude to how many factors should I consider for my further study and research. So this was just on the basis of that the regression made me choose that what should be my factors and what should I work for the future research for.
Okay, so are you also using the factor analysis for that?
Yes, I'll do that in future, sir, but not right now.
Not right. Okay, thank you.
Thank you, sir.
Okay, thank you everyone for your presence, and I would like to be with us and okay, so you guys can remove now, and from our side we are ending this. Thank you. Thanks.
Photo खींच लेता हूँ, photo. Kajewad, Udupi, Assam, Tamil Nadu, and Kerala. The conference is successfully executed on the hybrid mode. More than 40 papers presented in the hybrid mode. All the faculty members and research scholars had worked hand to hand to successfully organize this conference. All the support is in report by Dr. Rajiv Kumar, co-president AMEA, Dr. Anita Saxena, Dr. Alok Kumar, Mr. Ashok Sidhu, Dr. Gopal, Dr. Vamesh, and all research scholars of the mathematics department. We would like to expressly thanks to the invited speakers who came to AMEA as well as the nearly 80 people who participated in Scientific One Day International National Conference. Thanks to all.
Thank you, sir.
Now I would like to invite Dr. Avinav Saxena for word of thanks. Please unmute yourself.
ये क्या है आपकी सजेशन में ये वाला फंक्शन रिपोर्ट है इसका कन्वीनर ने रिपोर्ट
A very good evening to all of you. I, Dr. Raghunath Saxena, Department of Mathematics, FYCS, has feel honored and privileged to an opportunity to deliver the vote of thanks. I, on behalf of FYCS, I would like to express thanks, Registrar Sir, Associate Dean, Jyoti Ma'am, our Director Sir, and print media, and HOD Sir, all the HOD of different departments. I once again thanks everyone whose contribution has made this conference successful. Thank you so much, Jay.
Thank you, Arthur.